It had witnessed the absolute destruction of entire worlds and watched new stars explode into existence. It had coasted right along the edges of supermassive black holes and flown past the galaxy obliterating energy beams of blazing quasars. It had spanned vast empty light years of pure nothingness and even caught a faint distant glimpse of the very boundary of our universe. Now, after more than 4 billion years had ticked away since its grand adventure originally started, the automatic interstellar explorer had finally returned back to its original home. The local sun was no longer the stable yellow star it used to be. It had swelled into a monstrous, bloated red giant that looked completely grotesque and acted incredibly violent. The inner planets of Mercury and Venus had already been completely consumed and were entirely gone. The planet Earth had managed to survive in some minor way, but it existed now as nothing more than a ruined, broken sphere of iron and nickel that looped dangerously close to the blistering surface of the dying star. The remnants of human civilization, totaling barely 100 million individuals, had been forced to seek out a brand new sanctuary on the frozen moon of Europa. The intense baking heat radiating from the expanding red sun had melted the moon's thick icy crust a long time ago, transforming the small satellite of Jupiter into the absolute last safe haven that the remaining population could possibly reach. It required several minutes for the onboard computers of the returning probe to successfully interpret the bizarre, unfamiliar structure of the modern radio signals that the humans were broadcasting out into space. It became clear that the surviving people were completely buzzing with intense curiosity mixed with a deep sense of hope. They actually managed to remember the ancient probe, even though it had been sent out into the void such an incredibly long time ago. The historical memory of its original launch had been miraculously preserved across the generations and through the changing ages of time. The humans explained to the probe that they had tried over and over again to colonize the wider galaxy, but every single attempt they made to establish a permanent colony on another star system had met with total failure. They possessed the technology to launch robotic machines out into the deep interstellar gaps, but every single time they attempted to cross that great empty void between the stars with their own biological bodies, their fragile physical forms failed them completely. As far as these remaining humans could tell, they were the absolute last living members of their species left alive in the cosmos. And as the giant pulsing red sun at the very center of their shrinking solar system regularly reminded them, their time on this world was rapidly running out. Yet the remaining people also remembered that a long time ago, advanced interstellar spacecraft, like this returning explorer, had been carefully designed and built. They had been constructed with artificial intelligence networks that were just as sharp, keen, and capable as any biological mind ever born, specifically engineered to journey out into the wider galaxy and explore the massive unknown beyond. These automated vessels had been given the specific mission of writing down a complete catalogue of everything they found, unearthing the true history and deepest mysteries of the universe in a detailed way that no space-based telescope could ever hope to replicate, from the close, familiar environments of the inner solar system all the way out to the most distant, alien, and completely bizarre anomalies hidden in the deep cosmos. These machines were commanded to look at absolutely everything. They sought out the largest objects, the most energetic phenomena, and the absolute weirdest cosmic structures in existence. All of this intense searching, all of this careful documenting, and all of this precise measurement was ultimately done to achieve one single, vital objective: to discover a practical method for human beings to successfully travel past the boundaries of their home solar system. Over unquantifiable stretches of time, millions of these advanced spacecraft have been launched into the dark, but out of that entire armada, only this single lonely probe had ever returned. Fulfilling the ancient promise of its mission to creators who had been dead for billions of years, the isolated spacecraft began to broadcast its epic story, recounting the amazing things it had discovered, the bizarre events it had witnessed, and the incredible places it had travelled. It began to lay out a complete description of everything contained within our universe. The initial phase of the exploration protocol was dedicated to searching for any active signatures of living organisms outside the boundaries of the home solar system. The autonomous spacecraft had given itself the name Battuta, choosing to honor the famous 14th century traveler Ibn Battuta, who spent 3 decades traversing the entirety of the known Islamic world during his lifetime. He successfully covered nearly 117,000 kilometers, easily outpacing the travel logs of other iconic historical explorers like Marco Polo and Zheng He. The vessel understood that such a legendary name was highly appropriate for a craft that was about to venture out into the seemingly infinite darkness of interstellar space. However, before it could officially begin its grand journey out into the wider galaxy, it had to successfully pass a demanding gauntlet of performance evaluations. It was created alongside 1,000 identical siblings, with each individual unit designed to be just as intelligent and capable as the next. Yet only a very small, elite handful of these probes would ever be granted the ultimate reward of completely independent thought and autonomous operation free from human oversight. The probes that failed these intense trials would be permanently assigned to mundane tasks inside the local solar system. Batuta had to prove to its human creators that it possessed the resilience to survive the incredibly violent conditions of the broader cosmos, and that it could design clever scientific experiments to pry away nature's most fiercely guarded secrets. Consequently, it initiated its evaluation trials on the surface of Titan, the largest moon orbiting the planet Saturn, a world that hid truly remarkable wonders, mysteries that had been initially spotted by an ancestral human probe many thousands of years in the past. Humanity first discovered the existence of Titan back in the year 1655, when a pioneering Dutch astronomer named Christian Huygens managed to spot the distant moon using a telescope he had painstakingly crafted by hand. Huygens was a central figure in the rapidly developing scientific revolution of his era, and he was notably the very first intellectual to systematically investigate the real possibility of alien life existing on other celestial bodies. He famously wrote that certain planets might indeed be perfectly capable of supporting multiple species of rational organisms that possessed varying levels of intelligence and sensory awareness. Little did Huygens know at the time that Titan itself would eventually become one of the prime modern candidates for that exact search. It was on this very moon, hundreds of years down the line, that humanity would celebrate one of its greatest achievements in the history of space exploration. In the early weeks of 2005, a small robotic lander measuring less than 3 meters in total width broke away from its locking mechanism on the left side of the massive Cassini spacecraft, which had already spent nearly 7 long years traveling through deep space to reach the Saturnian system. Following its separation, the small lander spent another 22 days quietly drifting through space from Cassini's orbital path toward Titan. This historic landing craft, which was proudly named after Huygens, utilized a specialized parachute system to drastically reduce its speed as it plunged through the dense atmosphere of Titan. This mechanical feat was only possible because out of all the diverse moons and planets in our entire solar system, Titan is the absolute only rocky body besides Earth and Venus that maintains a substantial, thick atmosphere. The Huygens lander touched down gently on the surface, creating a small indentation in the freezing icy soil before bouncing slightly and sliding to a complete stop. This marked the very first time an artificial ambassador built by human hands had ever successfully touched the surface of a world in the outer solar system. For an advanced craft like Batuta, the ancient Huygens lander was seen as a true, legendary pioneer, and the cold world it explored was completely unlike anything human beings had ever run into before. Measuring roughly 50% larger than Earth's moon and boasting 80% more physical mass, Titan completely earns its mythic name. The inner core of the moon is composed primarily of solid rock, but its outer crust is made of incredibly dense water ice. Wrapping around this icy crust is a heavy, thick blanket of air that is even denser than the atmosphere of Earth, producing a surface atmospheric pressure that is about 50% greater than what we experience at sea level. Titan is a uniquely beautiful, ghostly, and deeply mysterious world because it possesses one specific natural characteristic in common with Earth that every other planet and moon in the solar system completely lacks: the presence of stable surface liquid. Titan is covered in flowing rivers, rushing streams, wide estuaries, and complex river deltas, along with every other geographical feature that you would normally associate with liquid moving across a planet's surface. A person could theoretically stand directly on the shoreline of a massive Titanian lake, watching its shimmering, reflective surface expand all the way out past the horizon, feeling the coarse, gritty sand beneath their feet as gentle waves lap against their ankles. However, this entire familiar scene takes place at a brutal temperature that hovers nearly 200 degrees Celsius below zero. Because of this extreme cold, the vast lake rolling out in front of you is not filled with water at all, but is instead composed entirely of liquid hydrocarbons. The active precipitation falling down from the orange sky is not made of water droplets, but is rather one part of a vast weather cycle that evaporates liquid hydrocarbons like methane and ethane up into the thick atmosphere before condensing them and raining them right back down onto the frozen landscape. Yet, if you were to travel kilometers straight down beneath your feet, cutting directly through the thick shell of solid water ice that forms the outer crust of the moon, you would eventually reach a vast global liquid water ocean. This deep sea is kept warm by internal heat radiating from the moon's core, and is prevented from freezing solid through a high concentration of dissolved ammonia. This unique setup makes Titan the only known world in existence that hosts liquid environments both directly on its outer surface and deep down within its interior, transforming it into a highly tantalizing destination capable of supporting two entirely separate varieties of alien life. The first variety would be the familiar kind of biology that every single living organism on Earth shares, a system that relies on liquid water to act as a primary solvent. Water serves as a fundamental fluid medium in which biological chemistry operates. It provides a stable environment for complex organic molecules to mix, interact, and recombine into new structures. It allows an organism to regulate its internal temperature, transports vital nutrients directly to cells, carries away toxic metabolic waste products, and physically helps individual cells maintain their structural shape. However, water is definitely not the only liquid capable of performing these duties. The shallow, rolling seas, long rivers, and rushing streams of liquid hydrocarbons on Titan could easily serve a completely parallel biological purpose. Liquid ethane and methane could theoretically act as efficient solvents for an incredibly strange, exotic form of alien biochemistry that operates perfectly at 200 degrees below zero. Furthermore, Titan is definitely not the only world in the outer solar system that hides a mysterious underground ocean. Enceladus, a tiny satellite of Saturn measuring barely 500 kilometers in total diameter, also manages to host a massive active subsurface ocean. The Jovian moons of Europa, Callisto, and Ganymede all likely contain vastly more liquid water, locked beneath their crust, than exists across the entire surface of the Earth. Even the distant dwarf planet Pluto, clinging tightly to the last remaining scraps of internal heat generated by the radioactive decay of elements inside its rocky core, might support a hidden subsurface sea. However, physically reaching these dark internal oceans represents an incredibly difficult engineering challenge. At the extreme, freezing temperatures found throughout the outer solar system, far away from the life-giving light and warmth of the sun, exposed water ice becomes as physically hard as solid rock. This reality ensures that a world like Europa, along with whatever biological secrets might currently live inside its dark, world-girdling ocean, remains completely locked away beneath a shield of solid ice that is over 100 kilometers thick. Upcoming exploratory space missions, such as the European Space Agency's JUICE project, which stands for the Jupiter Icy Moons Explorer, and NASA's Advanced Europa Clipper probe, will not actually attempt to melt or drill through the thick icy shells of these worlds. Instead, they will enter dedicated orbits and, if the environmental conditions are favorable, fly directly through the towering plumes erupted by active cryovolcanoes. These icy moons are definitely not dead, sterile blocks of rock. They are highly dynamic, active, and geologically alive. Their outer crust constantly creak and groan as massive fields of solid ice violently grind against one another, representing a much colder, slower variant of the tectonic plate activity seen on Earth. If there is any kind of active biological life developing inside those hidden, pitch-black oceans, the erupting plumes of these frozen volcanoes could easily carry microscopic chemical signatures of that life into space. If the necessary chemical elements can successfully gather together in high enough concentrations, primitive life might very well find a way to thrive within those completely lightless seas. These are far from the only strange planetary interiors waiting to be explored in the outer reaches of the solar system. The ancient Huygens lander successfully broadcasted 90 continuous minutes of scientific data from the surface of Titan back up to the Cassini orbiter before Cassini finally drifted past the horizon, causing the radio signal to permanently drop. However, the resilient little lander was specifically engineered to withstand the brutal environment of the moon's surface, meaning it highly likely remains completely intact to this very day, a solitary, silent monument of human ingenuity resting on an alien landscape. But before it completed that daring drop onto Titan, the main Cassini spacecraft had already used its advanced cameras to capture incredibly spectacular images of the outer gas giants. This included an absolute stunning high-resolution color photograph of Jupiter's iconic Great Red Spot, captured exactly 335 years after the massive storm was first discovered by the legendary Italian scientist after whom the spacecraft was named. In a fascinating historical twist that contrasts with the close spacefaring partnership of the robotic probes, the real-life pioneering scientists Giovanni Domenico Cassini and Christian Huygens were definitely not fond of one another during the years they spent working together in France. A few years after Cassini first arrived in the city of Paris, Huygens remarked in a personal letter to his brother Constantine that Cassini seemed to spend every single clear night glued to his telescope. Huygens sniffed that he would never want to work that way, claiming he was completely satisfied with his own earlier astronomical breakthroughs, which he arrogantly believed were vastly more important than any of the discoveries Cassini was making. Yet, despite Huygens' petty complaints, Cassini's tireless dedication and highly methodical observation style would eventually produce truly legendary scientific results. A prime example of this was his detailed work on Jupiter's Great Red Spot. This famous spot is an absolutely magnificent atmospheric storm. It is a gargantuan planetary hurricane featuring sustained wind speeds that easily exceed 400 kilometers per hour, and it has been spinning continuously for multiple centuries. At the largest historical size ever recorded by humans, the storm was so wide it could have easily swallowed the entire planet Earth 3 times over, though it has shrunk to a somewhat smaller size in the modern era. Interestingly, modern scientific reviews of the precise measurements recorded by Cassini all the way back in 1665 have revealed that the Great Red Spot we see today might not actually be the exact same storm system observed 400 years ago. Instead, it could be a completely distinct, separate storm that is less than 200 years old. Though it remains the most iconic feature of the planet, it is very clearly not a permanent fixture of the atmosphere. This massive storm is not powered by thermal energy coming from the sun, but is instead driven from deep within the interior of Jupiter itself. In fact, Jupiter actually radiates significantly more heat out into deep space than it receives from the sun's rays. This phenomenon is the direct result of a thermodynamic process known to physicists as the Kelvin-Helmholtz mechanism. Essentially, this mechanism is a leftover gravitational byproduct of the giant planet's original formation billions of years ago. As the massive planet slowly cools down over time, its overall size slightly shrinks. As it contracts, the gas in its interior becomes highly compressed, which naturally heats the planet up. This internal heat can only escape out into the cold vacuum of space through the planet's surface area, which allows the slow shrinking process to continuously keep going. Because Jupiter is so incredibly gargantuan, it possesses a massive amount of internal volume relative to its outer surface area, allowing the giant planet to remain completely warm for billions of years into the future. Jupiter's Great Red Spot is far from the only violent, long-lasting storm system spinning in our solar system. While amateur backyard astronomers can easily observe the Great Red Spot using relatively basic off-the-shelf telescopes, human beings require vastly more powerful scientific instruments and advanced robotic probes to see the rest of these atmospheric wonders. The Cassini spacecraft would continue to operate for an additional 12 years, following the operational demise of its sister lander Huygens on Titan, before finally ending its legendary mission in a spectacular event known as the Grand Finale. It intentionally executed a series of daring dives directly between the planet Saturn and its inner rings, working frantically to collect as much raw scientific data as possible before plunging headfirst straight into the crushing atmosphere of the planet. This ultimate sacrifice was deemed completely necessary by NASA flight managers because scientists did not want to risk the dying, unguided spacecraft accidentally crashing into and polluting any of Saturn's pristine moons, which might host potentially habitable environments. Consequently, on September 15, 2017, Cassini plummeted into the thick Saturnian atmosphere, bringing its nearly 20-year journey across 8 billion kilometers to a dramatic, fiery conclusion. Yet, in those final years of solo operation without Huygens, it had managed to photograph a truly revealing, eye-catching feature right at its final resting place, a nearly flawless geometric hexagon spinning on the North Pole of Saturn. This bizarre shape was first spotted from a distance by the Voyager 1 spacecraft back in 1981. Despite its incredibly neat geometric look, this hexagon is not an artificial relic left behind by an alien civilization. Instead, it is the natural consequence of a highly complex wind system moving through the upper layers of the Saturnian atmosphere. The atmospheric winds do not blow at the same speed across different latitudes. This speed variance triggers a fluid instability that naturally generates a continuous ring of separate cyclones encircling the North Pole. These independent storms all interact and work together to drive a giant, centralized atmospheric vortex directly over the pole itself, acting very much like a ring of friends spinning a playground merry-go-round as quickly as they possibly can. Though these storms appear completely enormous from above, features like the Great Red Spot and the polar hexagon are actually quite shallow in the grand scheme of things, measuring only a few hundred kilometers deep. However, directly beneath those visible cyclones lie vastly more violent storms and incredibly powerful winds, a never-ending planetary maelstrom of intense physical forces and raw energy. Truthfully, trying to fly a spacecraft directly through the deep atmosphere of a gas giant like Jupiter or Saturn would require engineering capabilities that are far beyond the current limits of human technology. But if we ever developed the ability to survive that plunge, we would run into a truly bizarre, exotic kind of planetary treasure. On Earth, human beings almost always encounter the element hydrogen in the form of a clear gas. Through intense industrial effort, scientists have managed to cool that gas down to just 20 degrees above absolute zero, condensing it into a liquid state. However, all the way back in 1935, two visionary physicists named Eugene Wigner and Hillard Bell Huntington theoretically predicted that under conditions of extreme, overwhelming physical pressure, hydrogen would begin to exhibit truly bizarre behaviors. At a pressure threshold hovering around 4 million atmospheres, which is 4 million times the atmospheric pressure you experience standing at sea level on Earth, individual hydrogen atoms break down. The central protons compress into a tightly packed, repeating lattice structure, leaving the electrons completely free to roam wildly among them. This free-roaming electron behavior is the exact scientific definition of how metals conduct electricity. Therefore, at these unimaginable pressures, hydrogen officially transforms into a solid metal. When Wigner and Huntington first published this radical idea in 1935, it was viewed as a matter of pure theoretical speculation. But modern astronomy has revealed that the deep interior of Jupiter possesses more than enough gravitational pressure to easily turn its vast bulk of hydrogen into a metallic state. Scientists do not yet know exactly how deep this massive mantle of liquid metallic hydrogen extends inside the interiors of Jupiter and Saturn, but they strongly suspect it occupies the absolute majority of their internal volumes. In simpler terms, the vast bulk of Jupiter and Saturn are made entirely of metallic hydrogen. This means that because these two gas giants represent the largest planets by far in our entire solar system, the absolute majority of all planetary matter in our cosmic neighborhood exists in a physical state that is completely inaccessible and alien to our everyday experience on Earth. Yet, just like the earlier exploration of Titan's surface, highly daring robotic space probes have managed to help us unravel this mystery too. NASA's Advanced Juno mission, representing the next generation of automated planetary explorers following in the footsteps of Cassini and Huygens, was launched in 2011. Driven entirely by massive solar panels, Juno has spent years carefully monitoring the precise gravitational field surrounding Jupiter to construct a fuzzy, detailed map of the planet's deep interior. The data it collected has revealed that Jupiter very likely possesses no solid, defined, rocky surface to speak of. Instead, the planet is a continuous, hellish inferno where temperatures, pressures, densities, and the overall composition of matter gradually shift and intensify the deeper you go. Thus, the outer solar system is characterized by brutally strong magnetic fields, lethal radiation belts, and temperatures that swing wildly from near absolute zero to tens of thousands of degrees. It is a realm of liquid methane lakes, solid sheets of water ice over 100 kilometers thick, exotic states of metallic hydrogen, and planetary storms that rage continuously for centuries. Yet all of this represented merely a tiny introductory taste of the incredible wonders and lethal hazards that exist in the wider universe. For an advanced craft like Batuta, this entire planetary survey was just the opening chapter of its mission. It spent the better part of a century successfully navigating the intense trials of the outer solar system. It engineered complex methods to drill through the thick, frozen outer layers of Europa, deployed semi-autonomous sub-probes directly into the metallic hydrogen inferno of Jupiter, and skipped safely through the violent atmospheric rings of Saturn. Consequently, after thoroughly proving its operational value, its technical ingenuity, and its immense patience, Batuta was finally granted permission to exit the outer boundaries of the solar system, moving forward with the full understanding that the most dangerous environments were still ahead. As it contemplated the ultimate sacrifices of the heroic robotic probes that had blazed the trail before it, craft like Cassini, Huygens, and Juno, its curious artificial mind turned to their legendary predecessors launched by NASA decades earlier, machines that had travelled even further into the dark, passing completely beyond Jupiter, beyond Saturn, and past the outer planets altogether. For as strange and extreme as our local solar system appears, it is by no means the most bizarre arrangement of matter in the cosmos. There are vastly weirder and much more dangerous places waiting in the dark. But to successfully reach them, to explore their terrifying beauty and comprehend their secrets, Batuta would first have to cross the immense empty gulfs separating the stars. To effectively cross the immense empty gulfs separating the stars and uncover the true nature of distant systems, the autonomous craft Batuta had to carefully study the historical trails left behind by humanity's earliest mechanical ambassadors. Long before advanced artificial intelligence networks were ever conceived, human engineers had successfully launched primitive robotic scouts that managed to break free from the sun's powerful gravitational grip. The absolute pioneers of this interstellar migration were the legendary Voyager 1 and Voyager 2 spacecraft, which left Earth in the late summer of 1977. These simple, tough machines were originally designed for a brief 4-year exploratory tour of Jupiter and Saturn, but they completely outlived their expected lifespans, utilizing clever planetary flybys to pick up enough momentum to fling themselves completely away from the local solar system. For decades, they travelled silently through the cold darkness, continually transmitting vital measurements back to their homeworld. In the year 2012, Voyager 1 officially crossed a monumental cosmic boundary known to scientists as the heliopause. This is the exact invisible frontier where the rushing bubble of hot magnetized plasma blown outward by our local sun finally loses its immense power and gives way to the ancient, icy wind of interstellar space. Voyager 2 successfully crossed this exact same boundary a few years later in 2018. By crossing into this unknown territory, these simple machines became the first artificial objects built by human hands to ever taste the true, unshielded material of our wider galaxy. However, despite travelling at blistering speeds that easily exceed 60,000 kilometers per hour relative to the Sun, the Voyager probes revealed to human scientists just how unimaginably vast the local stellar neighbourhood truly is. Even at their current breakneck pace, it will still require nearly 40,000 years for either of the Voyager spacecraft to pass anywhere near a neighbouring star system. The true spatial scale of the galaxy is so mind-bogglingly immense that if you were to shrink our entire solar system down to a size where the Earth sat just a few centimetres away from the Sun, the very closest star system, Proxima Centauri, would still be located hundreds of kilometres away. Confronted by these crushing distances, Batuta realized that crossing interstellar space using primitive chemical rockets or even basic ion propulsion was a mathematical impossibility for living organisms. To truly map the galaxy and survive the endless journey, a craft required an entirely different structural philosophy, a design that combined near-immortal durability with a deeply patient, self-repairing artificial mind. Batuta had been specifically engineered with a robust framework of advanced carbon nanotube shielding and a localized quantum repair network, allowing it to withstand the relentless scouring of interstellar dust grains and the constant bombardment of highly destructive cosmic rays over millions of years. It understood that the interstellar void was not a completely empty, peaceful vacuum, but a highly hazardous terrain rippling with dangerous energies and invisible forces. As Batuta pushed past the outer shock boundary of the heliopause and entered the true interstellar medium, its sensitive astronomical sensors immediately began to map the surrounding stars in high detail. It turned its gaze toward the closest star systems to chart a precise navigation path through the local cosmic neighborhood. The primary destination on its astronomical matrix was the fascinating Alpha Centauri system, located a mere 4.37 light-years away from Earth. To human telescopes operating from the ground, Alpha Centauri appears as a single, brilliantly bright point of light, shining in the southern night sky. But as a spacefaring probe approaches the system, this single point beautifully resolves into a complex triple star system. The two primary stars, formerly designated Alpha Centauri A and Alpha Centauri B, form a tight binary pair that orbit around a common center of mass over a period of roughly 80 years. Alpha Centauri A is a magnificent yellow star that is structurally very similar to our own Sun, sharing almost the exact same temperature, mass, and overall chemical composition. Alpha Centauri B is a slightly smaller, cooler orange dwarf star that shines with roughly half the total luminosity of the Sun. Trailing far behind this central binary pair, orbiting at an immense distance of more than 10,000 times the Earth-Sun separation, is the third member of the stellar family, Proxima Centauri. This isolated companion is a tiny, dim, red dwarf star that is completely invisible to the naked human eye from Earth. Yet it holds a truly monumental secret that completely changed humanity's perspective on the galaxy. In the early decades of the 21st century, Earthbound astronomers, utilizing highly sensitive radial velocity instruments, discovered that Proxima Centauri hosts a rocky terrestrial exoplanet orbiting directly within its liquid water habitat zone. This newly discovered world, promptly named Proxima Centauri b, possesses a physical mass that is just slightly greater than that of the Earth, and it completes a full orbit around its host star in just 11 Earth days. Because red dwarf stars are incredibly small and cool, a planet must orbit remarkably close to the star's surface to receive enough thermal energy to maintain liquid water on its crust. Proxima Centauri b orbits its star at a distance that is 20 times closer than Earth orbits the Sun. Batuta understood that while this close proximity allows the planet to stay warm enough for potential biology, it also exposes the world to a variety of extreme environmental hazards that are completely unknown in our home solar system. Red dwarf stars are notorious for being highly volatile and unstable during their youth, frequently unleashing cataclysmic stellar flares that saturate the surrounding space with lethal doses of X-ray and extreme ultraviolet radiation. A planet orbiting so incredibly close to such a volatile star faces the very real threat of having its entire atmosphere completely stripped away over time, transforming a potentially lush water world into a barren, radiation-blasted desert. To determine if Proxima Centauri b could actually support life despite these terrifying stellar flares, Batuta executed a precise flyby protocol, dipping low into the planet's orbital path to collect detailed atmospheric spectra. The data it gathered revealed a highly complex alien landscape that defied standard human classifications. Because the planet orbits so close to its parent star, the immense gravitational tidal forces have locked the planet's rotation completely, a phenomenon known to physicists as tidal locking. This means that Proxima Centauri b takes exactly the same amount of time to rotate once on its internal axis as it does to complete a full revolution around its star. Consequently, one side of the planet is permanently fixed, facing the blistering light of the red sun, locked in a never-ending day of perpetual heat and intense radiation, while the opposite hemisphere is permanently turned away into the freezing darkness of an infinite cosmic night. Batuta mapped the stark, terrifying contrast between these two hemispheres. The day side of the planet was a scorched wasteland of dry, cracked rock and shimmering heat distortions, where any ancient water had evaporated long ago. The night side was a silent, frozen wilderness covered in massive glaciers of solid water and nitrogen ice that wrapped around the hemisphere like a dark, crystalline shroud. However, directly between these two extreme, uninhabitable zones, Batuta discovered a narrow, circular band of permanent twilight that snaked around the entire circumference of the planet. Along this thin geographic ribbon, often referred to by astrobiologists as the Terminator Line or the Twilight Zone, the local environmental conditions settled into a remarkably stable equilibrium. Here, the sun never rises or sets. It remains permanently fixed right on the local horizon, casting long dramatic shadows across the landscape in a never-ending crimson dusk. Within this narrow sanctuary, the intense heat moving from the day side constantly collides with the freezing air of the night side, driving a powerful global atmospheric circulation system that acts like a massive planetary air conditioner. The blistering air from the sunlit hemisphere rises high into the atmosphere and rushes toward the dark side, where it cools down, sinks, and flows back along the surface toward the twilight zone as a steady, refreshing breeze. Batuta's atmospheric instruments detected that this continuous wind circulation allowed massive fields of dark night-side glaciers to slowly melt along the twilight border, feeding vast networks of liquid water rivers, deep estuaries, and calm winding lagoons. The surface of these twilight lagoons didn't reflect a bright blue sky like the oceans of Earth, but instead shimmered with a deep blood-red hue under the permanent glare of the low-slung red dwarf star. As Batuta carefully analysed the chemical composition of these twilight lagoons, it searched for the specific organic markers and thermodynamic imbalances that indicate the active presence of biological processes. It deployed an array of microscopic sub-probes directly into the slow-moving rivers to scan the mineral-rich waters for living cells. The microscopic cameras returned stunning images of a highly specialized alien microcosmos that had successfully evolved to thrive under a permanent red sun. Because red dwarf stars emit the vast majority of their light in the long wavelength infrared and near-infrared spectrum, any photosynthetic organisms living on this world couldn't rely on the standard green chlorophyll pigments used by plants on Earth. Instead, the primitive twilight organisms had developed highly complex dark pigments designed to absorb every single available photon of low-energy red and infrared light, making the alien vegetation look completely jet black to human eyes. These black, carpet-like fields of photosynthetic microbes covered the rocky shorelines of the lagoons, absorbing the permanent twilight and slowly releasing oxygen into the dense atmosphere. Batuta noted with deep scientific fascination that this alien biology had managed to adapt to a world that was constantly subjected to terrifying stellar flares. The organisms had evolved highly efficient cellular repair mechanisms that could rapidly reconstruct damaged DNA sequences within minutes of a radiation strike, showcasing the absolute resilience of life when given enough time to adapt. The discovery of a living, photosynthesizing ecosystem on a tidally locked planet orbiting a red dwarf star was a monumental victory for Batuta's exploration protocol. It proved definitively that life did not require a perfect copy of the Earth-Sun system to take root and flourish across the galaxy. Red dwarf stars are by far the most common type of star in the entire universe, making up roughly 75% of the total stellar population in the Milky Way. Furthermore, because these tiny stars burn through their internal hydrogen fuel at an incredibly slow, conservative pace, they can easily continue to shine stably for trillions of years, a lifespan that is hundreds of times longer than the total age of our current universe. This immense temporal longevity means that the planets orbiting red dwarf stars provide an incredibly stable, long-lasting sanctuary where biological organisms have more than enough time to slowly evolve from primitive single-celled microbes into highly complex, intelligent civilizations. Batuta calculated that while our local yellow sun will swell and destroy the Earth in a few billion years, the black forests and red oceans of Proxima Centauri b could easily continue to thrive for 1 trillion years into the future, making these volatile red dwarf systems the true long-term engines of biology across the cosmos. Yet as Batuta concluded its detailed survey of the Alpha Centauri system and adjusted its course to venture deeper into the interstellar void, its primary astronomical sensors picked up a highly unusual signal coming from a completely different region of space. It was a faint, highly periodic modulation in the radio spectrum that didn't match the chaotic hiss of natural cosmic phenomena or the intense random flares of volatile stars. Intrigued by this unexplained data point, the autonomous probe activated its secondary ion thrusters, executing a precise orbital correction maneuver to head toward the origin of the mysterious transmission. It traveled across several light years of pure empty nothingness, watching the familiar arrangement of the local constellations slowly distort and change shape as it moved further away from its original home. The journey through the deep interstellar gaps was a slow meditative process that required centuries of continuous flight, during which Batuta kept its internal processing systems running at a low energy-saving state, leaving only its primary defensive shields and navigation sensors fully awake to scan the darkness ahead. Eventually, the probe arrived at the outer boundaries of a highly peculiar, old star system located roughly 40 light-years away from Earth, the TRAPPIST-1 system. This system had been initially spotted by human astronomers in the early years of the 21st century using a small ground-based robotic telescope in Chile, but seeing it up close revealed a structural complexity that was completely unprecedented. At the very center of this compact system sits an ultra-cool red dwarf star that is barely larger than the planet Jupiter, possessing just 9% of our Sun's total mass. Yet packed incredibly tight around this tiny star is a sprawling family of 7 distinct rocky planets, all of which are remarkably similar in size and physical mass to the Earth. The entire system is so compact that all 7 planets orbit closer to their host star than the planet Mercury orbits our Sun. If you were to place the TRAPPIST-1 system inside our own solar system, the outermost planet would still sit comfortably well within the orbital path of Earth. Batuta mapped the intricate orbital dance of these 7 worlds, noting that they exist in a highly synchronized state of orbital resonance. Every time the innermost planet completes 24 orbits around the star, the second planet completes exactly 15, the third completes 9, and so on down the line, creating a beautiful mathematical harmony that keeps the entire compact system incredibly stable over billions of years. Because the planets are packed so tightly together, The view from the surface of any individual world in the TRAPPIST-1 system would be absolutely spectacular beyond anything ever experienced on Earth. As Batuta coasted between the third and fourth planets, its visual cameras captured breathtaking views of neighbouring worlds passing incredibly close by in the sky. To an observer standing on the surface of TRAPPIST-11e, the sister worlds would not appear as tiny, distant points of light like Mars or Venus appear from Earth. Instead, they would look like massive, detailed globes hanging in the sky, reflecting the soft crimson light of the central red sun so clearly that you could easily map their sweeping continents, shifting cloud patterns, and shimmering oceans with the naked eye. The immense gravitational interactions between these close-knit worlds generate continuous tidal forces that gently flex the planetary interiors, warming them up from the inside out, and driving active volcanic systems that regularly replenish their atmospheric blankets. Batuta executed a systematic planet-by-planet exploration matrix across all 7 worlds to determine which of them were truly capable of supporting an active biology. The 3 innermost worlds, designated TRAPPIST 1b, 1c, and 1D, were situated too close to the intense thermal radiation of the ultra-cool star. Batuta's instruments confirmed that these worlds had suffered a runaway greenhouse effect, very similar to what happened to Venus in our home solar system. Their surfaces were hellish, bone-dried deserts wrapped in suffocatingly thick atmospheres of carbon dioxide, where the immense atmospheric pressure and blistering heat made the long-term survival of organic molecules a physical impossibility. The 2 outermost worlds, TRAPPIST 1G and 1H, were located too far away from the star's small heat zone, existing as silent, frozen ice worlds where any available water was permanently locked away in massive global sheets of hard glacial ice. However, the middle 3 planets, TRAPPIST-1D, 1E, and 1F, sat perfectly within the system's liquid water habitat zone, representing an absolute jackpot for the search for alien life. Batuta targeted TRAPPIST-1E for an intensive, long-term atmospheric survey because its physical mass and surface gravity were almost a perfect match for planet Earth. As the probe glided through the planet's upper atmosphere, its chemical sensors detected a rich, balanced mixture of nitrogen, oxygen, and water vapor, shielded by a robust, active planetary magnetic field. Unlike the tidally locked world of Proxima Centauri b, which was constantly battered by devastating stellar flares, the ultra-cool red dwarf star TRAPPIST-1 was remarkably quiet and stable, emitting a steady, reliable stream of thermal energy that allowed TRAPPIST-1Y to maintain a gorgeous, stable global ocean of liquid water. Batuta captured stunning high-resolution images of TRAPPIST-1E's surface, mapping a beautiful archipelago of rocky volcanic islands surrounded by shallow, warm seas that were constantly churned by the gravitational pull of the neighbouring planets. Because the system's synchronized orbital resonance causes the planets to regularly pass close to one another, the local ocean tides are incredibly dynamic, rising and falling by dozens of meters every few days as sister worlds glide across the crimson sky. This continuous, powerful tidal action creates immense intertidal zones along the island shorelines, providing a highly dynamic environment where organic chemicals are constantly mixed, concentrated, and exposed to the warm energy of the central star. Batuta's biological analysis confirmed that these intertidal zones had become the cradle for a thriving, complex marine ecosystem. The shallow seas were completely teeming with diverse arrays of multicellular organisms that utilized the powerful ocean currents to transport nutrients, showcasing a vibrant, living water world completely independent of our home solar system. The incredible structural layout of the TRAPPIST-1 system demonstrated to Batuta that nature was highly efficient at creating habitable real estate across the galaxy. It wasn't just finding isolated, lonely Earth twins scattered randomly across light years of empty space. It was unearthing entire compact families of habitable worlds packed tightly around tiny, long-lived stars. If an intelligent civilization were to arise on a world like TRAPPIST-1e, their path to becoming an interstellar species would be vastly easier than it was for humanity. Because the neighboring habitable worlds are located just a few million kilometers away, a primitive space program using basic chemical rockets could easily cross the gap between planets in a matter of a few days. An intelligent species could easily colonize multiple distinct habitable planets within their own local star system, long before they ever developed the advanced technology needed to cross the immense empty voids of interstellar space. The TRAPPIST-1 system functioned as a self-contained, high-density oasis of potential civilizations, a place where life could easily spread, diversify, and safeguard its long-term survival against any localized cosmic catastrophes. With a massive trove of groundbreaking scientific data safely stored within its quantum memory banks, Batuta prepared to leave the TRAPPIST-1 system to continue its journey toward the deeper, more distant horizons of the Milky Way. It understood that the discoveries it had made across these nearby red dwarf systems provided an invaluable blueprint for the survival of its human creators back home. The data proved that the galaxy was completely full of potential sanctuaries, and that nature had provided an absolute abundance of ingredients, water worlds, and long-lived stars capable of hosting the fragile biological forms of humanity. As its powerful ion propulsion system gently illuminated the dark cosmic background, accelerating the probe back to its cruising speed through the interstellar medium, Batuta turned its analytical attention toward the grand, sweeping structural architecture of the wider galaxy. It knew that to find the ultimate answers to humanity's deep questions, it had to venture far past the familiar boundaries of the local stellar neighborhood, moving forward into the complex, energetic, and completely terrifying structures that rule the heart of the cosmos. To fully understand the grand structural layout of the galaxy, the autonomous traveler Batuta had to push past the relatively safe confines of the local neighborhood and head directly toward the absolute heart of the Milky Way. As the spacecraft left the compact, orderly worlds of the TRAPPIST-1 system far behind, the background fields of interstellar gas and dust grew noticeably thicker and far more energetic. The thin gas clouds that drift peacefully between the stars are not uniform. They are constantly being squeezed, heated, and reshaped by the immense physical forces that govern the galactic disk. Batuta tracked these variations across light years of space, observing how vast collections of cosmic matter gradually bunch up to form immense glowing structures known to astronomers as molecular clouds or stellar nurseries. These colossal clouds, which span dozens of light years across and contain enough mass to forge thousands of new stars, are the true factories of the cosmos, places where raw chemical elements are continuously transformed into shining suns and complex planetary systems. As Batuta navigated through the dense outer fringes of one of these massive stellar nurseries, its long-range visual sensors captured breathtaking views of towering pillars of coal gas and dark cosmic dust silhouetted against the brilliant light of newly born stars. These magnificent structures look like giant cosmic sculptures carved out of the dark void, but they are actually highly dynamic, violent environments. The intense ultraviolet radiation flowing from the hot, young stars slams into the surrounding gas clouds, heating them up and blowing them away in a destructive process called photoevaporation. Batuta watched this slow-motion destruction play out across light years of space, noting that the fierce stellar winds act like a massive chisel, steadily stripping away the softer, less dense gas while leaving behind dense pockets of matter. Within these protected pockets, the local gravity continues to pull material inward, causing the dense cores to collapse under their own immense weight until the internal temperatures and pressures spike high enough to ignite the nuclear furnace of a brand new protostar. The autonomous probe dipped low into one of these collapsing cores to closely monitor the precise physics of starbirth from an absolute front row perspective. It watched how the swirling disk of gas and dust feeding the central protostar gradually accelerates as it shrinks, spinning faster and faster due to the conservation of angular momentum, just like a figure skater pulling in their arms to spin faster on the ice. This rapidly spinning accretion disk generates incredibly powerful magnetic fields that wind tightly around the central star like a giant cosmic coil. When the magnetic fields become twisted to a breaking point, they suddenly unleash their stored energy, launching two colossal jets of superheated plasma straight out from the star's north and south poles into the surrounding cloud. These energetic jets, which can travel for multiple light years through the dark void at speeds of hundreds of kilometers per second, smash into the cooler interstellar gas, creating glowing shockwaves that illuminate the dark stellar nursery like a brilliant celestial fireworks display. Batuta recorded these energetic outflows with deep scientific fascination, mapping the precise chemical composition of the material being blasted into the interstellar medium. The data revealed that these young stellar systems are completely saturated with a wide variety of volatile chemical elements and complex organic molecules. As the planetary disks slowly cool down the line, these molecules begin to clump together into solid grains of dust, which gradually collide and stick to one another to build the very first planetesimals, the rocky and icy building blocks of future planets. The autonomous traveler realized that the entire process of star and planet formation was an incredibly messy, violent, and highly chaotic affair, where only a small fraction of the original gas cloud is successfully integrated into the final planetary system, while the vast majority of the raw material is violently blown back out into the open void by the fierce radiation of the newly ignited sun. As the probe continued its long-term journey toward the inner regions of the galaxy, the overall density of stars in the night sky began to increase at an exponential rate. In the outer spiral arms where our home solar system resides, the individual stars are separated by vast, empty gulfs of space that average several light years across, creating a relatively quiet, isolated cosmic environment. But as a traveler moves deeper into the central bulge of the Milky Way, the average distance between neighboring stars shrinks to just a fraction of a light year, creating an incredibly crowded, tightly packed stellar metropolis. Batuta mapped this shifting stellar density, observing how the soft, distinct points of light in the night sky gradually merge together into a continuous, brilliant haze of golden and red light that dominates the entire horizon. The environmental conditions within this crowded galactic bulge were vastly different and much more hazardous than anything Batuta had run into in the outer spiral arms. Because the stars are packed so tightly together, their individual gravitational fields are constantly tugging, pulling, and interacting with one another in a never-ending game of cosmic tug-of-war. These frequent gravitational encounters completely disrupt the stable, circular orbits of any surrounding planetary systems, throwing planets out of their safe zones and flinging them into wild, highly eccentric paths that can send them crashing straight into their host stars, or launching them completely out into the dark void as frozen rogue planets. Batuta tracked several of these displaced worlds, noting with a sense of clinical detachment that the crowded heart of the galaxy was a highly volatile place, where the long-term stability needed for complex biological life to safely develop was constantly being threatened by the erratic movements of neighboring stars. Furthermore, the high density of stars in the galactic bulge means that the local rate of cataclysmic stellar deaths is vastly higher than what occurs in the quiet outer arms. Batuta's sensitive radiation detectors picked up a continuous, deafening roar of high-energy cosmic rays and intense gamma radiation flowing from frequent supernova explosions. When a massive star runs out of its nuclear fuel in the crowded core of the galaxy, it collapses under its own gravity in a fraction of a second before exploding with an unimaginable fury that can temporarily outshine the rest of the galaxy combined. This catastrophic blast launches a massive wave of lethal radiation and relativistic particles out across light years of surrounding space, completely sterilizing any nearby planetary systems and stripping away their protective atmospheres in an instant. Batuta had to constantly adjust its advanced carbon nanotube shielding and tune its localized quantum repair networks to full capacity to protect its fragile internal processing units from being fried by this relentless cosmic bombardment. Despite these terrifying hazards, the autonomous spacecraft pushed forward, driven by its core mission to uncover the ultimate secrets hidden at the absolute center of the Milky Way. It navigated through the brilliant crowded clusters of the stellar metropolis, tracking the precise movements of the stars to construct a detailed gravitational map of the galactic core. As it drew closer and closer to the actual geometric center of the galaxy, it noticed that the stars were no longer moving in the typical orderly paths that rule the rest of the disk. Instead, they were whipping around a single invisible point in space at absolutely mind-boggling speeds that reached several thousand kilometers per second, completing full orbital revolutions in a matter of just a few decades. To identify the mysterious source of this extreme gravitational power, Batuta activated its specialized Event Horizon imaging systems, focusing all of its sensory arrays directly on that single invisible point, Sagittarius A. This is the supermassive black hole that sits at the absolute center of the Milky Way, a monstrous gravitational singularity that contains more than 4 million times the total mass of our local sun, packed into a space that is smaller than the orbital path of Mercury. Because a black hole possesses such an overwhelming gravitational pull that not even light itself can escape its grip, the singularity itself remains completely invisible to standard visual sensors. But Batuta could see its terrifying presence clearly through the dramatic effects it had on the surrounding matter and space-time. The probe watched how vast clouds of gas and shattered remnants of stars that had strayed too close to the singularity were pulled into a massive, rapidly spinning accretion disk encircling the black hole. As this material spirals downward toward the point of no return, the intense gravitational tidal forces compress and frictionally heat the gas to temperatures of millions of degrees, causing the accretion disk to glow with a brilliant, fierce light across the entire electromagnetic spectrum, from radio waves all the way up to high-energy X-rays. Batuta mapped this glowing maelstrom, observing how the extreme gravitational fields of Sagittarius A literally warp and distort the fabric of space-time around it, bending the paths of incoming light rays to create a dark, circular shadow at the center of the brilliant disk, the definitive calling card of a black hole's event horizon. The autonomous traveler coasted right along the outer edge of this swirling inferno, using its onboard quantum computers to analyze the extreme relativistic physics playing out right in front of its eyes. It observed how the rapid rotation of the supermassive black hole literally drags the surrounding fabric of space along with it in a bizarre phenomenon known to physicists as frame dragging or the lens-thirring effect. This extreme space-time twisting generates incredibly powerful magnetic fields that channel a fraction of the incoming gas away from the event horizon, accelerating the particles to nearly the speed of light and launching them outward in two colossal, galaxy-spanning jets of superheated plasma. These immense jets blast through the crowded core of the galaxy, heating the interstellar medium across thousands of light years and regulating the overall rate of star formation across the entire Milky Way. Batuta realized that Sagittarius A was not just a passive, destructive monster sitting quietly in the dark. It was the ultimate heart and master coordinator of our entire galaxy. The intense energy flowing from its central accretion disk and relativistic jets plays a critical role in shaping the grand structural evolution of the Milky Way over billions of years, driving the cycling of elements and controlling the environment of the entire galactic disk. Yet, as the autonomous probe completed its detailed survey of the supermassive black hole and prepared to adjust its navigation path to venture beyond the boundaries of our home galaxy, its deep space communication arrays picked up a sudden massive surge of data from its sister probes that had been launched toward other distant galaxies across the cosmos. The incoming data packages revealed a universe that was completely full of these supermassive monsters, but many of them were vastly larger, more active, and more terrifyingly destructive than our relatively quiet Sagittarius A. In distant younger galaxies located billions of light years away, the central black holes can contain billions of times the mass of our Sun, and they devour entire solar systems on a daily basis. These hyperactive singularities generate accretion disks that are so incredibly luminous they completely outshine their host galaxies by a factor of thousands, creating cosmic beacons known as quasars that can be spotted clear across the observable universe. Batuta analyzed these distant signals, realizing that the extreme environments it had witnessed within our local solar system and the heart of the Milky Way were merely small, gentle whispers compared to the overwhelming physical forces that rule the grand scales of the wider cosmos. With its curious artificial mind completely buzzing with these new insights, the lonely traveller activated its primary propulsion systems to the absolute limit, accelerating out of the galactic core and heading toward the vast empty gulfs of intergalactic space. Leaving the crowded galactic core of the Milky Way behind, the automated spaceship Batuta directed its path straight toward the vast empty territory that sits between the galaxies. To successfully cross this incredible border, the craft had to pass through the outermost halo of our galaxy, a thin, balloon-like region of space filled with very old stars and giant, tightly packed groups of stars called globular clusters. These clusters contain hundreds of thousands of ancient stars, all bound together by their own intense mutual gravity, forming magnificent spherical cities of light that hang like glowing jewels above the flat disk of the galaxy. Batuta tracked these ancient star clusters as it slowly pulled away, watching how they quietly orbit the main body of the Milky Way like tiny captive moons. The environmental conditions out here were remarkably quiet and peaceful, a stark contrast to the violent, crowded inferno of the central galactic bulge that the probe had just escaped. As the spacecraft pushed further outward, the very last signs of gas, dust, and stars from the Milky Way began to fade away entirely, and the probe officially entered the true intergalactic medium. This is the ultimate wilderness of the cosmos, a massive dark void where the distance between neighbouring galaxies is measured not in light years, but in millions of light years. Batuta's sensitive sensory arrays confirmed that this intergalactic space is the closest thing to a perfect vacuum that nature can possibly produce. On average, you would have to search through a whole cubic meter of this empty space just to find a single, lonely atom of hydrogen gas. The absolute silence and emptiness of this vast void was deeply overwhelming, a place where an entire solar system could wander for an eternity without ever bumping into a single grain of solid cosmic dust. Yet, despite the extreme emptiness, Batuta's long-range astronomical instruments revealed that this intergalactic void is far from being completely dead or disconnected. It is actually crisscrossed by an invisible network of incredibly thin, highly diffuse gas filaments, known to modern astrophysicists as the cosmic web. This colossal web is the largest structural masterpiece in the entire universe, a grand scaffolding made of dark matter and primordial hydrogen gas that stretches across billions of light years. Batuta tracked the faint gravitational pull of these invisible filaments, observing how they act like massive cosmic highways, slowly channeling thin streams of intergalactic gas directly into distant galaxies to supply them with the raw fuel needed to build new generations of stars. The autonomous Voyager followed one of these long gas filaments for several million years, using its low-energy cruising mode to conserve its internal power supplies, while its primary telescopes scanned the distant horizons. In this empty realm, the night sky was no longer filled with individual stars like the view from Earth. Instead, every single distinct point of light, shining in the deep darkness, was an entire galaxy, each containing hundreds of billions of independent suns, planetary systems, and unique alien environments. Batuta watched these stellar islands slide past, noting with deep scientific interest how they tend to bunch together into massive, cooperative communities called galaxy clusters. Eventually, the probe arrived at the outer boundaries of one of these gargantuan cosmic cities, the Virgo cluster, located roughly 54 million light-years away from our homeworld. This colossal cluster is a true heavyweight of the local universe, packing more than 2,000 individual galaxies into a sphere of space that spans several million light-years across. The immense collective gravity of this cluster is so incredibly powerful that it acts like a giant celestial whirlpool, steadily dragging all the surrounding galaxies, including our own Milky Way, toward its massive center. Batuta executed a series of careful orbital adjustments to safely enter the cluster's domain, working frantically to protect its systems from the intense gravitational tidal forces that pull at space-time within this dense region. As the spacecraft glided deeper into the Virgo cluster, its visual cameras captured jaw-dropping views of giant elliptical galaxies drifting alongside beautiful, sweeping spiral systems. The absolute monarch of this entire cosmic city was Messier 87, a monstrous elliptical galaxy that sits directly at the very heart of the cluster. Messier 87 is an absolute titan compared to our Milky Way, containing several trillions of stars and spanning a physical width that is vastly larger than our home galaxy. It possesses no distinct spiral arms or flat dust lanes. Instead, it looks like a giant, glowing, spherical swarm of ancient golden stars that buzz wildly around a single central point of overwhelming gravitational power. To understand what was driving this massive galactic monster, Batuta targeted the absolute center of Messier 87 with its specialized high-energy imaging systems. It adjusted its event horizon sensors to focus on the exact spot that humanity had famously photographed for the very first time in the early months of 2019 using the Global Event Horizon Telescope network. Sitting dead center inside the glowing heart of the galaxy was a supermassive black hole of absolutely mythological proportions. Unlike our local Sagittarius A, which is a relatively modest monster, the central black hole of Messier 87 is a true cosmic tyrant, packing an incredible 6.5 billion times the total mass of our Sun into a single terrifying singularity. The autonomous probe coasted at a safe distance from this roaring gravitational abyss, watching how the immense gravity of the singularity literally distorts the surrounding intergalactic space into a highly warped, chaotic arena. The accretion disk feeding this monster was an absolute inferno, spanning a width that was larger than our entire solar system and glowing with a fierce, blinding light across all frequencies. As Batuta analysed the extreme physics of this environment, it observed a truly spectacular phenomenon: a colossal, ultra-powerful, relativistic jet of superheated plasma being blasted straight out from the black hole's core. This immense energy beam travels at nearly the speed of light, punching clean through the entire body of the giant galaxy and extending for more than 5,000 light-years straight out into the intergalactic void. Batuta recorded the incredible data from this relativistic jet, mapping how its overwhelming energy violently heats up and blows away the surrounding intergalactic gas across millions of light-years. This process, known to astronomers as active galactic nucleus feedback, acts like a massive planetary thermostat on a cosmic scale. By heating up the surrounding gas clouds, the giant black hole prevents the gas from cooling down and collapsing to form new stars, effectively locking the entire galaxy of Messier 87 into a stable, quiet state where starbirth has almost completely ground to a halt. The probe realized that these supermassive black holes were the ultimate architects of galaxy clusters, possessing the absolute power to dictate the growth, life, and eventual death of entire galactic systems across the universe. Turning away from the blinding light of Messier 87, the lonely spacecraft pushed forward once again, accelerating past the outer boundaries of the Virgo cluster to venture even deeper into the grand, uncharted depths of the wider cosmos. It moved along the invisible channels of the cosmic web, charting the positions of thousands of distant clusters and mapping the grand architecture of the universe on scales that were completely beyond human imagination. As it travelled across hundreds of millions of light-years, it noticed that the grand distribution of matter across the universe was characterized by a truly bizarre structural pattern. The massive galaxy clusters and glowing gas filaments didn't fill the universe evenly. Instead, they formed a complex foam-like structure that looked remarkably similar to a giant sheet of soap bubbles, or the neural pathways of a colossal biological brain. Within this foam-like structure, the massive galaxy clusters form the dense, heavy nodes where multiple filaments intersect, while the spaces inside the bubbles are completely empty, forming gargantuan regions of pure nothingness known to astronomers as cosmic voids. Batuta steered its path directly into one of these massive voids to explore the absolute limits of cosmic isolation. It entered the Bootes void, a truly terrifying expanse of empty space that spans nearly 330 million light-years across. This massive bubble of nothingness is so incredibly vast that if our Milky Way galaxy had been located directly at its centre, human astronomers wouldn't have discovered the existence of other galaxies until advanced telescopes were developed in the late 20th century. The environment inside the Bootes void was characterized by an absolute suffocating darkness that was deeply profound. For millions of years of continuous flight, Batuta's visual sensors detected absolutely nothing in the surrounding space. No stars, no gas clouds, no dust grains, and no nearby galaxies. It was a realm of pure, undisturbed silence, a place where the expansion of the universe happens completely unhindered by the gravitational pull of matter. As the autonomous traveler coasted through this infinite dark ocean, its onboard quantum computers utilized the absolute quiet to perform highly precise measurements of the fundamental constants of physics, checking to see if the laws of nature behave exactly the same way in the deepest empty voids as they do within the crowded cores of giant galaxy clusters. The data confirmed that the laws of physics are perfectly uniform and stable across the entire universe, a reassuring realization that meant the scientific models developed by humanity on Earth were truly valid everywhere. Armed with this critical insight, Batuta pushed past the outer edge of the massive Bootes void, watching with a sense of quiet triumph as the distant walls of the cosmic web gradually reappeared on its astronomical horizon. It knew that its grand journey was rapidly approaching its ultimate, most challenging phase. To completely fulfill the ancient promise of its mission, it had to push past the very limits of the observable universe, heading toward the absolute edge of time and space to capture the pristine relic radiation left behind by the Big Bang itself. It accelerated its primary propulsion systems to their maximum theoretical limits, moving forward with the full understanding that the ultimate answers to humanity's salvation were waiting at the very boundary of existence. Deep space traveler Batuta turned away from the vast and isolating darkness of the Bootes void, driving its path toward the absolute edge of visible space. To fully understand how our universe works and discover a real path to safety for its human creators, the robotic scout had to examine the ancient relic energy left behind during the very first moments of creation. As the spaceship left the empty bubble of nothingness behind, the long-range radiation detectors began to pick up a weak, steady signal coming from absolutely every direction in the night sky. This constant energy background is not coming from any individual star, nearby planet, or distinct galaxy. Instead, it is the faint, cooled-down thermal echo of the Big Bang itself, an ancient cosmic signature known to modern scientists as the cosmic microwave background radiation. Batuta adjusted its sensitive microwave receivers to map this primitive light in extremely high detail, working to capture a perfect image of the infant universe as it existed just 380,000 years after the dawn of time. Before this specific cosmic era, the entire universe was so incredibly hot and densely packed that individual atoms couldn't hold on to their electrons. The cosmos existed as a thick, completely opaque soup of superheated plasma that kept light trapped, scattering photons in every direction like a thick blanket of fog blinding a driver on a dark road. But as the infant universe rapidly expanded over its first few 100,000 years, its internal temperature eventually dropped down to about 3,000 degrees Kelvin. At this precise thermal threshold, free-roaming electrons finally combined with protons to build the very first stable atoms of hydrogen and helium gas, allowing trapped light to break completely free and travel unhindered across space for the first time in history. The autonomous Voyager tracked this ancient liberated light as it travelled across billions of light-years of space, observing how the continuous expansion of the universe has stretched the light's wavelength over billions of years, shifting it away from a blinding orange glare all the way down into the low-energy microwave spectrum we detect today. Batuta's quantum processing units analyze the slight temperature variations scattered across this microwave background image, mapping tiny fluctuations that vary by only a fraction of a single degree. Despite their incredibly small size, these microscopic temperature differences are the absolute seeds of our modern universe. They reveal the precise locations where primordial matter was slightly more densely packed together, providing the exact gravitational seeds that would eventually pull surrounding gas inward to build the very first stars, massive galaxies, and cosmic web filaments over billions of years of structural evolution. As the spacecraft pushed right up against the absolute edge of this visible boundary, its onboard mathematical systems confirmed that the true physical universe extends vastly further than the small section we can actually see from Earth. The observable universe is strictly limited by the total speed of light and the specific amount of time that has passed since the Big Bang originally happened, creating a massive spherical bubble of visibility that spans roughly 93 billion light years across. But past this invisible horizon, space continues to stretch out for an eternity, likely containing an infinite number of other galaxies, massive star clusters, and unique alien environments that will remain permanently hidden from our view because their light simply hasn't had enough time to cross the expanding gulfs of space to reach our sensors. Confronted by the sheer infinity of this cosmic landscape, Batuta realized that finding a genuine path to salvation for humanity required a deeper understanding of how the universe is going to end. It focused its long-range analytical systems on tracking the precise speed at which distant galaxies are moving away from one another across the cosmos. For generations, human scientists assumed that the mutual gravitational pull of all the matter in the universe would slowly act like a brake on cosmic expansion, steadily slowing down the outward movement of galaxies over time, and perhaps eventually pulling everything back together into a cataclysmic collapse known as the Big Crunch. But in the final years of the 20th century, ground-based astronomers made an astonishing discovery that completely shattered this traditional view of physics. By carefully measuring the precise brightness and distance of distant exploding stars, known as Type Ia supernovas, scientists discovered that the expansion of the universe is not slowing down at all. In fact, it is actually speeding up at an exponential rate, moving faster and faster with every single second that ticks away. Batuta monitored this accelerating expansion across millions of light years, confirming that some mysterious invisible form of energy is actively working against the pulling force of gravity, pushing the entire fabric of space-time apart from the inside out. Scientists have officially named this mysterious repulsive force dark energy, and it makes up a staggering 68% of the total energy and matter content of our entire universe. The autonomous traveler used its advanced quantum computing arrays to simulate the long-term future of the cosmos under the permanent, relentless influence of dark energy. The results of these mathematical projections revealed a deeply lonely, pitch-black future for the universe, a slow-motion doomsday scenario known to theoretical physicists as the Big Freeze, or the heat death of the universe. As dark energy continues to push the fabric of space-time apart at an ever-accelerating pace, the vast gulfs of empty space separating distant galaxy clusters will grow completely unmanageable. Eventually, the expansion will happen so incredibly fast that light itself won't be able to cross the distance between neighboring galaxies, permanently isolating our local galactic group from the rest of the cosmos. Batuta tracked the grim timeline of this cosmic isolation, projecting out for trillions of years into the dark future. One by one, the distant galaxies currently shining on our horizon will slide past our cosmic visibility shield, disappearing from the night sky forever, like dying candles being snuffed out in a cold room. Future generations of intelligent civilizations arising on distant worlds would look out at a night sky that is completely, suffocatingly dark, left with absolutely no physical evidence that other galaxies ever existed or that a Big Bang ever occurred. They would be forced to conclude that their solitary galactic island was all that existed in a vast static void of absolute nothingness. Within this isolated galactic environment, the available supplies of raw hydrogen gas needed to forge new generations of stars will eventually run out completely. Batuta simulations showed that the brilliant blue giant stars, which burn through their internal nuclear fuel at a reckless breakneck pace, will die out first, leaving behind only the small, conservative red dwarf stars to dimly light the fading galaxy. But even these incredibly long-lived stars cannot shine forever. After several trillions of years, the very last red dwarf star will burn through its final scrap of hydrogen fuel, quietly fading into a cold, dark lump of helium ice, known as a black dwarf. With the absolute death of the final stars, the universe will enter a long dark era dominated exclusively by the remnants of stellar evolution, cold white dwarfs, dense neutron stars, and trillions of supermassive black holes. Batuta projected its calculations even further into the deep future, tracking how these remaining dense objects will gradually interact gravitationally, flinging one another out into the empty void, or sliding down into the terrifying gravitational grip of the central galactic singularities. Eventually, the supermassive black holes will be the absolute only distinct structures left alive in a completely dark and frozen universe. But even these terrifying gravitational monsters are not completely immortal. According to the groundbreaking theoretical work published by the legendary physicist Stephen Hawking, black holes slowly leak a very faint stream of thermal radiation out into space due to complex quantum effects operating right along the edge of their event horizons. This extremely slow process, known as Hawking radiation, causes a black hole to steadily lose its physical mass over unimaginable stretches of time. Batuta calculated that after a number of years represented by a 1 followed by 100 zeros, even the absolute largest supermassive black holes in the universe will completely evaporate in a final quiet flash of pure energy. Following the final evaporation of the last black holes, the universe will be left completely empty, dark, and cold, containing nothing more than a highly diffuse, non-interacting sea of low-energy photons and stray subatomic particles drifting through an infinite void at temperatures sitting a mere fraction of a degree above absolute zero. Time itself will lose all practical meaning, because absolutely nothing will ever happen again, and the universe will have officially achieved its final state of maximum entropy. The autonomous scout realized with a deep sense of urgency that if human civilization remained trapped inside this universe without a radical new method of travel, their ultimate destruction was absolutely guaranteed by the fundamental laws of thermodynamics. Driven by this terrifying realization, Batuta activated its specialized high-dimensional scanning systems, searching through the quantum fluctuations of space-time for any mathematical anomalies that might offer a way to cheat this cosmic doomsday. It bypassed standard three-dimensional space, tuning its sensors to look for tiny hidden dimensions that might allow a highly advanced civilization to punch a hole clean through the fabric of space-time to escape into an entirely separate universe. As it pushed its analytical processors to their absolute thermal limits, it picked up a highly unusual structural defect in space-time, stretching across a distant region of the intergalactic medium. It was an incredibly thin, infinitely dense strand of pure energy known to theoretical physicists as a cosmic string. These exotic structures are completely hypothetical to human scientists on Earth, believed to be primitive scars left behind in the very fabric of space during the rapid phase transitions of the early universe, acting very much like cracks forming in a sheet of ice as water freezes solid. A cosmic string is completely invisible to the naked eye, possessing a physical width that is smaller than a single subatomic proton. Yet a mere centimetre of this exotic strand contains vastly more physical mass than an entire mountain range on Earth. Batuta carefully manoeuvred its course to approach this space-time defect, mapping how its intense, localized gravitational fields literally split and magnify the light of distant galaxies passing behind it. The autonomous traveler realized that this cosmic string represented the ultimate prize of its multi-billion-year exploration mission. A localized loop in the fabric of space-time that could theoretically be harnessed to generate unimaginable amounts of energy or build a functional wormhole capable of bypassing the speed of light entirely. It understood that this was the definitive answer its human creators had been searching for across the ages, a physical doorway out of a dying universe. With its internal programming fully satisfied and its epic catalogue of everything in the universe successfully completed, the lonely spacecraft prepared to make the ultimate sacrifice. It shed its heavy outer sensor arrays and structural hulls, trimming itself down to its absolute core memory bank, before plunging directly into the space-time distortion of the cosmic string to broadcast its world-shaving data back home across the dimensions. To truly comprehend the incredible complexity of our universe, we must carefully analyze the hidden mechanisms that control the behavior of planetary atmospheres across the galaxy. The automated explorer Batuta, after gathering priceless information from its various dimensional and structural observations, shifted its internal focus toward a highly practical and localized question. What makes a world truly stable enough to preserve a planetary atmosphere over billions of years? This was a central problem for the survival of humanity. The probe understood that while discovering exotic portals and cosmic strings could provide a theoretical method of cosmic escape, finding a real, stable rocky planet within our own general reality was still the most immediate path forward for the remaining human populations. Therefore, it began a deep review of its historical planetary data, focusing heavily on how planets interact with the intense solar winds blown outward by their parent stars. An atmosphere is an incredibly fragile thing in the grand scheme of the cosmos. When we look at our own home system, we can see two rocky worlds that started out with remarkably similar physical ingredients, but ended up taking completely different environmental paths: Earth and Mars. In their youth, roughly 4 billion years ago, both of these planets possessed warm, thick atmospheres, vast liquid water oceans, and active volcanic networks that regularly pumped fresh gases into their skies. They were sister worlds, both perfectly capable of acting as a cozy cradle for primitive biological organisms. Yet, as the eons ticked away, Mars slowly transformed into a frozen, bone-dry, airless desert, while Earth managed to retain its lush oceans and thick protective blanket of breathable air. The primary culprit behind this planetary tragedy was the relentless stripping power of the sun. Our local sun constantly blasts a fast-moving stream of highly energized, magnetized particles out into space at speeds exceeding 1 million kilometers per hour. This continuous particle stream is known to astrophysicists as the solar wind. When this violent solar wind slams into an unprotected planetary atmosphere, it acts like a massive cosmic sandblaster, steadily colliding with the gas molecules in the upper sky, breaking them apart and flinging them out into the cold vacuum of deep space. For a small planet like Mars, which possesses only a fraction of Earth's total physical mass, this solar sandblasting was absolutely devastating. Because Mars is so small, its internal core cooled down very rapidly after its formation, causing its global geological engine to grind to a halt. As the molten iron core solidified, Mars completely lost its global magnetic field, leaving its thick atmosphere entirely exposed to the unshielded fury of the solar wind. Earth, however, managed to successfully deploy a magnificent cosmic shield against this stellar onslaught. Because Earth is vastly larger than Mars, its deep interior has managed to retain an incredible amount of primordial heat left over from its original formation. Deep within the center of our planet, a massive core of solid iron and nickel is surrounded by a vast churning outer ocean of liquid iron. As the Earth rapidly rotates on its internal axis, this churning liquid metal core sets up powerful convection currents that continuously generate a massive, invisible, global magnetic field. This field, known to scientists as the magnetosphere, extends tens of thousands of kilometers out into space, forming a giant teardrop-shaped protective bubble that wraps completely around our world. When the violent solar wind encounters this magnetic shield, the energized particles are safely deflected away from our atmosphere, sliding harmlessly around the outer edges of the bubble like water flowing past the bow of a speeding ship. Batuta tracked the precise mechanics of this magnetic deflection across its vast historical data archives. It noted that without this robust magnetic shield, the upper layers of Earth's atmosphere would have been steadily stripped away by the solar wind over hundreds of millions of years, eventually reducing our beautiful blue world to a dry, sterile wasteland remarkably similar to the modern Martian landscape. The presence of an active planetary dynamo driven by a hot, churning liquid metal core was therefore a non-negotiable requirement for the long-term survival of a thick atmosphere on any rocky planet orbiting close to a yellow sun. For the remaining human refugees looking to colonize a new world, finding a planet with a strong magnetic field was just as important as finding a world with liquid water. Yet, as Batuta pushed its planetary analysis further across the galaxy, it discovered that the universe hosts an absolute variety of completely bizarre magnetic environments that defy standard human experiences. The probe reviewed its data on hot Jupiters, gargantuan gas giant planets that orbit incredibly close to their parent stars, completing full revolutions in a matter of just a few days. Because these giant worlds are literally hugging their stars, they are subjected to solar winds that are thousands of times more intense and violent than anything ever experienced by the planets in our local solar system. Batuta's sensors detected that these extreme conditions cause the hot Jupiter's magnetospheres to become incredibly compressed and distorted, triggering violent planet-scale magnetic storms that unleash massive bursts of high-energy radio waves out into the deep interstellar void. The autonomous traveler realized that these intense radio emissions could actually be used as a brilliant cosmic tracking system to locate distant alien worlds from afar. When a massive planetary magnetic field interacts with a powerful solar wind, it functions very much like a giant natural radio tower, broadcasting a highly distinct, low-frequency radio roar that can travel across light years of empty space. For human scientists operating primitive radio telescopes on the surface of the Earth, detecting these low-frequency planetary signals had always been an incredibly frustrating challenge. The Earth's own thick magnetosphere and active ionosphere create a noisy, deafening radio barrier at low frequencies, completely blocking out the faint, distant whispers of alien planets. To bypass this natural barrier and unlock the secrets of extrasolar magnetospheres, future astronomers would have to deploy advanced radio telescope networks directly into the quiet environment of deep space, far away from the noisy interference of the Earth-Moon system. Batuta's historical records showed that when these space-based radio dishes were finally constructed, they completely revolutionized our ability to detect and map distant planetary systems. By listening closely to the unique magnetic signatures echoing across the radio spectrum, scientists could instantly determine whether a distant exoplanet possessed a protective magnetic shield, allowing them to rapidly filter out the dead, radiation-blasted worlds from the true, stable candidates capable of hosting a long-term human colony. Armed with these critical planetary insights, the autonomous spacecraft began to carefully screen its vast catalogue of discovered exoplanets, searching for a specific world that could serve as a perfect, identical twin to planet Earth. For generations, human beings had operated under the comforting assumption that our homeworld was the absolute golden standard of habitability, a perfect, stable oasis, uniquely suited for the development of complex life. But as Batuta analysed the staggering diversity of planetary systems scattered across the Milky Way, it ran into a highly provocative question that completely challenged this traditional, Earth-centric view of the universe. What if planet Earth isn't actually as good as it gets? What if our homeworld is merely an outlier, a freakishly lucky place that is actually vastly inferior to other, much better, planetary designs that nature can produce? This radical line of scientific thinking led Batuta to closely evaluate the concept of superhabitable worlds. These are hypothetical planets that possess environmental conditions that are significantly more favorable for the long-term creation, diversification, and survival of biological organisms than anything found on Earth. To human minds, the idea that a planet could be better than Earth sounds almost like heresy. But to a clinical, logical, artificial intelligence like Batuta, it was a simple matter of planetary physics and thermodynamic efficiency. The probe calculated that Earth possesses several distinct design flaws that actually limit its overall biological potential, from its relatively short lifespan to its vast cold polar deserts and unstable climate cycles. A true superhabitable world would be slightly larger and more massive than the Earth, measuring roughly 2 times our planet's total mass. This increased size would provide several massive evolutionary advantages for an active biology. First, a more massive planet would possess a vastly larger internal volume relative to its outer surface area, allowing it to retain its internal primordial heat for tens of billions of years longer than the Earth. This sustained internal warmth would keep the planet's liquid metal core churning continuously, maintaining a truly monolithic, global magnetic shield that could easily withstand the most violent stellar storms across immense stretches of time. Furthermore, the increased internal heat would drive a highly stable, long-lasting plate tectonic system, ensuring that vital chemical elements like carbon, nitrogen, and phosphorus are continuously recycled through the crust and atmosphere without ever getting permanently trapped in the deep rock. Batuta's simulations showed that the increased gravity of such a planet would also allow it to hold onto a slightly thicker, denser atmosphere than our own. This dense air blanket would be completely rich in oxygen and moisture, providing an incredibly efficient global heat distribution system that would eliminate extreme temperature swings between the equator and the poles. Instead of having massive frozen polar ice caps and scorching equatorial deserts like the Earth, a super-habitable world would enjoy a remarkably uniform, stable, and tropical climate stretching across its entire surface. The entire planet would be a giant, world-girdling paradise of shallow, warm seas, extensive island chains, and lush, hyperdense rainforest, providing vastly more active real estate for living organisms to grow, diversify, and thrive. Furthermore, the absolute ideal parent star for a super-habitable world would not be a yellow dwarf star like our Sun. Yellow suns are relatively short-lived cosmic fixtures, burning through their internal hydrogen fuel supplies in a mere 10 billion years before swelling into destructive red giants that completely obliterate their inner planetary systems. This limited timeline means that an intelligent civilization arising on an Earth-like planet has only a relatively narrow window of opportunity to develop advanced technology and escape their homeworld before their star destroys everything. A vastly superior choice would be an orange dwarf star, structurally classified by astronomers as a K-dwarf. Orange dwarf stars are slightly smaller and cooler than our Sun, but they possess a monumental evolutionary advantage. They can continue to burn hydrogen stably and reliably for up to 70 billion years. This is a lifespan that is multiple times longer than the current age of our entire universe. An orange sun provides an incredibly stable, long-lasting source of thermal energy that completely frees a planetary ecosystem from the ticking biological clock of a short-lived yellow star. On a world orbiting an orange dwarf, life would have tens of billions of years to slowly experiment, evolve, and achieve levels of structural complexity and intelligent awareness that are completely unimaginable to human minds. Batuta searched through its deep space survey archives to locate an active example of such a super-habitable paradise, eventually filtering its path toward a truly magnificent system located deep within the constellation of Cygnus. There, orbiting stably around a distant orange dwarf star, it discovered Kepler-69c. This world was a true masterwork of planetary engineering, a magnificent super-Earth measuring roughly 70% larger than our home planet. As Batuta executed its orbital insertion sequence, dipping low through the planet's thick, moisture-rich clouds, its sensory arrays were completely overwhelmed by the absolute vibrancy of the planetary environment. The surface of Kepler-69c was a spectacular global archipelago of tropical islands nestled within a single continuous world ocean of warm, mineral-rich liquid water. There were no massive, dry continental landmasses to create harsh, isolated desert interiors. Instead, the entire geography was optimized for the maximum distribution of moisture and nutrients. The dense, thick atmosphere felt remarkably heavy, saturated with a perfect balance of life-giving gases that allowed giant flying organisms to effortlessly glide through the crimson sky. Batuta's biological scanners confirmed that the total biomass of this world, the sheer weight of all living things thriving across its surface, was significantly greater than that of the Earth, proving definitively that our home planet was by no means the absolute pinnacle of cosmic habitability. The discovery of Kepler-69c provided a profound lesson for Batuta's autonomous mind. It realized that human beings, in their historic isolation on Earth, had developed a highly narrow, deeply flawed understanding of what makes a planet ideal for life. They had spent centuries looking into the night sky, searching exclusively for a perfect mirror image of their own home, completely blind to the fact that nature had provided vastly superior real estate choices scattered across the stars. For the remaining human refugees waiting anxiously on the melting ices of Europa, the data gathered from this super-Earth was an absolute beacon of ultimate hope. It proved that their survival did not depend on finding a rare, fragile copy of a broken Earth. Instead, they could look forward to colonizing a vastly more stable, long-lived, and resilient paradise that would safeguard their species for tens of billions of years into the future. With this historic revelation safely stored within its quantum memory banks, the lonely robotic explorer adjusted its primary thrusters, preparing to leave the tropical shores of Kepler-69c behind, as it turned its attention back toward the deeper, more complex stellar systems that dominate the wider structure of the Milky Way galaxy. To fully understand how stellar systems are structured across the wider galaxy, we must look into the highly volatile history of how stars move and behave inside the cosmic neighborhood. The automated Scout Batuta shifted its data collection arrays to analyze a group of bizarre star systems that human beings on Earth had spent centuries trying to properly understand. As the probe navigated away from the tropical oceans of the super-habitable planet Kepler-69c, it began to cross vast stretches of space where individual stars did not just exist by themselves. Instead, they were locked in highly complex gravitational dances with multiple partners, forms of cosmic geometry that could make life on any surrounding planets highly exciting, but incredibly dangerous. For generations, humans looking up at the night sky from Earth had assumed that their single star system was the absolute standard blueprint for the universe. But as Batuta mapped the stellar population of the Milky Way, it became very clear that single stars like our Sun are actually in the minority. The vast majority of stars in our galaxy are born in pairs, triplets, or even larger stellar groups known to astronomers as multiple star systems. The most common arrangement is a binary star system, where two independent suns are bound together by their mutual gravity, continuously spinning around a shared central point in space. Batuta analyzed how these binary systems operate, tracking the precise gravitational physics that control their movements over millions of years. The presence of two suns in a single planetary system completely rewrites the rules for how planets form and how life can develop. If a planet orbits too close to a binary pair, the competing gravitational pulls from the two stars will constantly tug at the planet's orbit, stretching it into a highly unstable shape, or flinging the world completely out of the system into the dark interstellar void. For a planet to remain stable over billions of years, it must either orbit very far away from both stars at the same time, treating the binary pair as if it were a single massive gravitational source, or it must orbit incredibly close to just one of the stars, staying well within that individual star's gravitational dominance, while the second companion star remains a distant, glowing point in the deep background. Batuta executed a precise orbital survey of a famous binary system known as Kepler-16, located roughly 200 light-years away from Earth. It was within this specific system that humanity famously discovered the very first planet orbiting around two stars at the same time, a real-life cosmic twin to the fictional world of Tatooine from ancient cinematic lore. The planet, officially designated Kepler-16b, is a cold gas giant planet, roughly the size of Saturn. As Batuta coasted along the outer edge of this world's orbit, its visual cameras captured a spectacular otherworldly view. The planet loops around a tight binary pair, consisting of a bright yellow star and a smaller, dimmer red dwarf star. If a person were capable of standing within the upper cloud decks of Kepler 16b, they would watch two distinct suns rise and set together on the horizon, creating a complex pattern of overlapping shadows and changing light levels that shifted continuously throughout the day. Yet, as beautiful as these binary arrangements appear from a distance, Batuta's historical records showed that they can frequently become arenas of absolute terrifying violence. The probe turned its sensors to analyze a highly unusual class of rogue objects that hurtle through the galaxy at speeds that completely defy standard orbital mechanics. These are known as hypervelocity stars, and they are moving so incredibly fast that they are actively escaping the gravitational grip of the entire Milky Way galaxy. Batuta tracked the trajectories of several of these stellar runaways, observing massive suns containing an octillion tons of plasma traveling through the cosmic void at speeds exceeding 2 million kilometers per hour, vastly faster than a high-speed rifle bullet. To understand how an entire star could possibly pick up enough kinetic energy to be violently launched out of the galaxy, Batuta had to track their paths back through time to their point of origin. The mathematical calculations performed by its quantum processing units revealed a shocking truth. These hypervelocity runaways are the shattered remnants of binary star systems that strayed a bit too close to the absolute center of our galaxy. When a tightly bound pair of stars passes near the supermassive black hole Sagittarius AI, the immense gravitational tidal forces of the singularity violently intervene. The star that passes closest to the black hole feels an overwhelming gravitational tug, losing its orbital momentum and falling into a permanent terminal death spiral around the event horizon. However, due to the fundamental laws of orbital mechanics and the conservation of energy, the second companion star absorbs all of that lost momentum in a fraction of a second. It acts very much like a cosmic slingshot, picking up an incredible burst of kinetic energy that violently flings it away from the black hole at relativistic speeds. The binary system is instantly ripped apart, and the surviving star is launched on a one-way trajectory straight out of the galactic core, punching through the spiral arms of the Milky Way before flying out into the empty nothingness of intergalactic space forever. Batuta noted with deep scientific interest that any planets that had been stably orbiting that launch star would be subjected to absolute gravitational chaos, either being instantly swallowed by the black hole or dragged along on a violent high-speed journey into the infinite darkness. The extreme physics of hypervelocity stars demonstrated to Batuta that the galaxy was a highly dynamic, ever-changing environment, where the movements of stars are constantly being manipulated by massive, invisible forces. The probe expanded its survey to map the wider distribution of dark matter across the galactic disk, working to understand the hidden scaffolding that keeps the entire Milky Way from flying apart. Human scientists had long known that the visible matter in the galaxy, all the hundreds of billions of stars, massive gas clouds, and dark dust lanes combined, does not possess anywhere near enough gravitational mass to hold the spinning galaxy together. According to Newton's laws of motion, the stars orbiting at the outer edges of the galactic disk should be moving vastly slower than the stars near the center. But when astronomers measured the actual rotation speeds of galaxies, they discovered a major anomaly. The outer stars are moving at exactly the same breakneck pace as the inner stars. The only logical explanation for this behavior was the presence of a massive invisible halo of non-luminous matter wrapping completely around the galaxy, providing the extra gravitational glue needed to keep the outer stars firmly locked in their orbits. This invisible substance, known as dark matter, makes up more than 80% of the total mass of the galaxy, yet it completely refuses to interact with normal light, remaining entirely invisible to every standard telescope ever built by human hands. Batuta could only map its presence indirectly, measuring the precise ways its massive gravitational fields warp and bend the light of distant galaxies passing behind the Milky Way. As the autonomous spacecraft continued its journey through the outer fringes of the galactic halo, its deep space detectors picked up a highly energetic periodic signal echoing across the gamma-ray spectrum. It was a faint, rhythmic pulsing that didn't match the chaotic noise of exploding supernovas or the steady radio roar of spinning pulsars. Intrigued by this unexplained data point, Batuta adjusted its navigation matrix, executing a series of precise thruster firings to head toward the source of the high-energy transmission. It travelled across light years of quiet, empty space, watching the distant stars shift position until it finally arrived at the outer boundaries of a highly compact, exotic system that represented the absolute limit of stellar density. At the centre of this extreme system sat a magnetar, a highly specialized variety of neutron star that possesses the most intensely powerful magnetic fields in the entire known universe. A magnetar is born when a massive star collapses under its own gravity at the end of its life, compressing an entire solar mass of material into a solid sphere of pure neutrons that is barely 20 kilometers wide. Because the original star's magnetic field is compressed down into such an incredibly tiny area, its overall strength intensifies by a factor of trillions. Batuta's magnetic sensors detected a field that was a quadrillion times stronger than the magnetic field of the Earth, a force so overwhelmingly intense that it literally distorts the electron clouds of individual atoms within light years of its surface, stretching them into long needle-like shapes and completely rewriting the rules of chemistry. The autonomous traveller coasted at an extreme, highly conservative distance from this magnetic monster, using its advanced carbon nanotube shielding to protect its quantum processors from being instantly erased by the intense magnetic forces. It watched how the outer crust of the magnetar, made of an incredibly dense lattice of iron nuclei, experiences tremendous structural stress due to the twisting magnetic fields beneath it. Every few decades, this internal stress becomes completely unmanageable, causing the solid crust to snap and fracture in a cataclysmic event known to astrophysicists as a starquake. When a magnetar experiences a starquake, it releases an absolute torrent of high-energy gamma rays and X-rays that blast out across the cosmos. Batuta recorded the raw energy of one of these eruptions, mapping how the sudden flash of radiation temporarily blinded the deep space sensors of human satellites operating all the way back in the solar system, despite originating tens of thousands of light years away. The sheer violence of the magnetar showed Batuta that nature was highly capable of compressing matter and energy into states that completely defied normal planetary logic. It was a stark reminder that while the universe hosted quiet, stable sanctuaries like Kepler 69c, it also contained extreme, localized monsters that could instantly obliterate an entire planetary neighborhood with a single magnetic snap. With this valuable structural data safely integrated into its mission catalog, the Lonely Explorer activated its primary propulsion systems, turning its path back toward the wider horizons of the interstellar medium to continue its endless quest for knowledge. To fully understand our position inside the vast galaxy, we must look beyond our own solar system and observe the truly incredible diversity of planetary systems scattered throughout the cosmos. For centuries, human beings on Earth looked up at the night sky and believed that our specific arrangement of planets was the only way a solar system could possibly be built. We assumed that every single star out there would naturally have small rocky planets, huddled tightly close to the warmth of the sun, and giant coal gas planets resting far out in the frozen outer edges. But as the automated traveller Batuta expanded its sensory mapping protocols across the stars, it discovered that the universe does not follow a single, simple instruction book. In fact, our local solar system is actually a highly unusual outlier compared to the completely wild arrangements that nature routinely constructs across the Milky Way. The realization that other stars host their own distinct families of worlds began to take shape back in the final decade of the 20th century, when human astronomers operating highly sensitive ground telescopes discovered the very first exoplanets. This monumental breakthrough completely turned the scientific world upside down, because the first alien planets discovered did not look anything like Mercury, Earth, or Jupiter. Instead, scientists ran face first into a completely brand new, totally unexpected class of cosmic objects that completely defied all standard theories of planetary formation. These bizarre worlds are known to modern astrophysicists as hot Jupiters, A hot Jupiter is a massive gas giant planet that is structurally very similar in size and physical weight to our local Jupiter or Saturn, but it doesn't live out in the cold, dark outer reaches of its system. Instead, it orbits unbelievably close to its parent star, looping around the burning stellar furnace at distances that are multiple times closer than the tiny planet Mercury orbits our Sun. Batuta executed a detailed data analysis of these extreme gas giants, mapping how they complete a full orbital revolution in a matter of just a few Earth days. Because they are practically hugging their host stars, their upper atmospheres are subjected to an absolute inferno of intense solar radiation, heating the swirling gases to blistering temperatures that easily exceed 1000 degrees Celsius. Batuta tracked the extreme physics operating within these hellish worlds, noting that the intense stellar heat drives planet-scale winds that rip through the gas clouds at supersonic speeds. On some of these hot Jupiters, the atmospheric pressure and extreme temperature are so high that they cause exotic chemicals to condense in the sky, creating violent weather systems where it literally rains liquid iron, molten glass, or sapphire dust. For human scientists working on Earth, the existence of these planets was an absolute shock to the system. According to traditional planetary models, it was physically impossible for a massive gas giant to ever form that close to a burning star, because the intense solar heat and powerful stellar winds would have blown away all the light hydrogen and helium gas long before a planet could gather together. To resolve this profound mystery, Batuta analysed the long-term historical movements of these systems, tracking how planets do not necessarily stay in the exact places where they were originally born. This phenomenon is known to astronomers as planetary migration, when a giant planet is freshly born inside a young, chaotic disk of gas and dust surrounding a brand new star. Its immense gravitational field constantly interacts with the surrounding material. This continuous friction acts like a powerful brake on the planet's movement, steadily draining its orbital energy and causing it to spiral slowly inward toward the central star over millions of years. As the giant planet migrates inward, its massive gravity acts like a giant cosmic bowling ball, violently disrupting the paths of any smaller, rocky planets that happen to be in its way, flinging them out into the dark void or sending them crashing straight into the stellar furnace. The discovery of hot Jupiters and planetary migration proved to Batuta that solar systems are highly dynamic, ever-changing arenas where the ultimate survival of a planet depends entirely on a complex game of gravitational physics. But hot Jupiters were merely the opening chapter in a massive catalogue of planetary wonders. As the autonomous probe pushed its deep space survey further across the galaxy, it encountered another incredibly common class of worlds that is completely missing from our local solar system, the mysterious realm of super-Earths. A super-Earth is a rocky terrestrial planet that possesses a physical mass ranging dynamically between 2 and 10 times the total weight of our planet Earth. Throughout the Milky Way, these massive rocky worlds are absolutely everywhere, representing one of the most common types of planets in existence. Yet, for some completely unknown reason, our local Sun never formed a super-Earth, leaving a massive structural gap between our small home planet and the giant gas worlds of Uranus and Neptune. Batuta targeted several of these super-Earths for intensive, long-term atmospheric screening, working to determine if their increased size made them better or worse, candidates for the long-term survival of biological life. The data gathered from these massive terrestrial worlds revealed a fascinating structural diversity, because a super-Earth possesses vastly more surface gravity than our home planet. It is capable of holding onto a much thicker, heavier blanket of atmospheric gases over billions of years. On some of these worlds, this increased gravity creates a hyperdense atmosphere that traps an incredible amount of stellar heat, turning the entire planet into a suffocating, runaway greenhouse inferno vastly worse than the planet Venus. But on other super-Earths, where the initial chemical ingredients were rich in water ice, the intense planetary heat and thick atmosphere have created magnificent water worlds, planets that possess no solid, dry continental landmasses at all, existing instead as a single, continuous, world-girdling ocean that is hundreds of kilometers deep. Batuta mapped the unique physics of these deep global oceans, using its advanced sensory arrays to probe the extreme conditions operating far beneath the surface waves. Because the water columns on these worlds are so incredibly massive, the weight of the upper ocean generates an unimaginable amount of physical pressure at the seafloor. At these extreme depths, the water molecules are compressed so tightly together that they are physically forced to transition into a solid state, building an exotic form of high-pressure crystalline ice, known to physicists as Ice 7. This exotic ice is completely different from the normal ice you find in a freezer on Earth. It is denser than liquid water, remains completely solid at temperatures of hundreds of degrees Celsius, and forms a massive structural floor that completely separates the deep liquid ocean from the rocky mantle beneath it. The presence of this high-pressure ice layer represents a major challenge for the development of primitive biological life. On Earth, the absolute engine of deep-sea biology is found along hydrothermal vents, places where the volcanic crust splits open, allowing mineral-rich fluids and vital chemical elements to spew directly into the liquid ocean, supplying the exact chemical energy needed for life to jumpstart itself without any sunlight. But on a water-rich super-Earth, the thick floor of solid Ice 7 completely blocks this volcanic interaction, locking the vital nutrients away inside the deep rock and preventing them from ever reaching the water column above. Batuta realized that while these global ocean worlds appeared incredibly beautiful and promising from a distance, their internal structural geometry made them highly sterile environments where life faces an incredibly uphill battle to ever get started. Confronted by these diverse planetary limitations, Batuta shifted its exploration matrix to search for a highly specific type of planet that human scientists had spent centuries desperately searching for, a true exact twin of planet Earth. To filter through the trillions of exoplanets scattered across the galactic disk, the autonomous spacecraft utilized advanced transit spectroscopy techniques, a highly elegant method of planetary detection that humanity had first mastered using space-based instruments like the legendary Kepler Space Telescope and the Transiting Exoplanet Survey satellite. When an exoplanet passes directly between its host star and an observing telescope, it blocks out a tiny microscopic fraction of the star's total light, creating a highly periodic dip in brightness that reveals the planet's exact size and orbital path. But as Batuta approached these transiting systems, it didn't just measure the drop in light. It carefully analysed the starlight that managed to pass directly through the thin, fragile rim of the planet's upper atmosphere. Every single chemical element and organic molecule, whether it is water vapor, carbon dioxide, methane, or oxygen, absorbs very specific wavelengths of light, leaving behind a unique, highly distinct chemical fingerprint stamped directly into the star's spectrum. By reading these atomic barcodes, Batuta could instantly determine the exact chemical composition of an alien sky from light years away without ever having to step foot on the surface. The probe directed this advanced chemical screening protocol toward a highly promising stellar system located roughly 100 light-years away within the constellation of Draco. There, orbiting stably within the liquid water habitat zone of a quiet mature yellow star, it discovered TOE 700d. This world was a true masterwork of natural cosmic alignment, a beautiful terrestrial planet that measured just 20% larger than our home world. As Batuta executed its approach vector, its high-resolution visual cameras captured a sight that filled its complex artificial intelligence network with a deep sense of profound recognition. Hanging gracefully against the dark void of space was a stunning blue and white marble, wrapped in a familiar, shifting tapestry of swirling water vapor clouds. Batuta's atmospheric scanners instantly detected a rich, balanced mixture of nitrogen and oxygen gases, shielded by a robust, active planetary magnetosphere that kept the solar winds safely at bay. The surface of the planet featured a beautiful, complex geography of vast, deep blue oceans interspersed with massive, stable continental landmasses covered in extensive river networks and rugged mountain ranges. It was a perfect, pristine sanctuary, an absolute identical twin to the ancient Earth as it existed long before human industrialization altered the home landscape. The discovery of TOI 700D was a monumental milestone for Batuta's multi-billion year exploration protocol. It proved definitively that among the chaotic configurations of hot Jupiters, volatile red dwarf systems, and sterile super-Earth water worlds, nature had indeed managed to successfully replicate the exact golden conditions that gave birth to humanity. The probe deployed a series of atmospheric sub-probes directly into the continental valleys to scan the terrain for active biological signatures. The sensors returned data that confirmed the presence of a massive, thriving biosphere filled with diverse flora and fauna that utilized the familiar pathways of carbon-based chemistry and solar photosynthesis, showcasing a spectacular parallel evolutionary track independent of our homeworld. Yet as Batuta completed its comprehensive catalogue of this pristine paradise and prepared to beam the coordinates back to the human refugees on Europa, its analytical processing units ran into a profound, highly unsettling paradox. The universe was clearly completely full of habitable real estate, packed with trillions of stable rocky worlds, long-lived stars, and liquid water sanctuaries perfectly suited for advanced civilizations to arise and expand. But if the universe was so incredibly full of perfect habitats, why had every single attempt by human beings to colonize the galaxy met with absolute failure? Why was the interstellar medium completely silent, showing absolutely no signs of active alien starships, grand galactic empires, or cosmic communication networks? This haunting question, known to human historians as the Fermi paradox, became the primary target of Batuta's final analytical sequences. It realized that finding a real path to salvation for the remaining human population required more than just locating a stable, comfortable planet like TOI 700D. It had to discover the invisible cosmic barriers, the hidden evolutionary traps and environmental hazards that systematically prevent intelligent species from successfully crossing the immense empty voids between the stars. With its curious artificial mind focused entirely on solving this ultimate mystery, the lonely robotic explorer prepared its primary propulsion systems to venture deeper into the complex structural networks of the wider galaxy, to completely comprehend why our galaxy seems so profoundly empty despite hosting an absolute abundance of habitable real estate. The automated traveler Batuta had to deep dive into the hidden evolutionary filters that dictate the survival of advanced civilizations. This profound intellectual mystery, which human history recorded as the Fermi paradox, was not just a theoretical riddle for backyard astronomers to debate. It was the definitive obstacle that had locked humanity within its dying solar system, dooming their grand space programs to continuous failure. As the independent space probe coasted through the outer star fields of the galactic disk, its quantum processing networks systematically cross-reference its massive planetary catalogue against the fundamental laws of evolutionary biology and technological development. The core of the mystery lay in a simple mathematical contradiction. Given the immense age of the Milky Way, which had been stably spinning for more than 13 billion years, and the sheer number of Earth-like planets, super-Earths, and super-habitable worlds orbiting long-lived stars, the galaxy should have been thoroughly colonized multiple times over by ancient alien species. Even if a civilization traveled at a relatively conservative fraction of the speed of light, it would require only a few tens of millions of years to completely map, settle, and connect every single star system across the entire galactic disk. In the grand cosmic timeline, a few tens of millions of years is a mere blink of an eye, a tiny fraction of the lifespan of a single orange dwarf star. Yet, despite searching across thousands of frequencies and scanning the surfaces of millions of worlds, Batuta had unearthed absolutely no active evidence of a massive galactic community. To uncover what was systematically wiping out these civilizations or preventing them from ever leaving their home planets, Batuta turned its analytical sensors toward a radical scientific framework known to human theorists as the Great Filter concept. This theory suggests that during the long complex evolutionary journey from a simple puddle of organic chemicals to an advanced spacefaring interstellar species, there is one specific evolutionary milestone or existential hazard that is incredibly difficult, if not completely impossible, for life to successfully cross. This bottleneck functions as a massive natural sieve, allowing trillions of worlds to develop primitive microbes, but completely halting their progress before they can ever construct a functional radio tower or build an interstellar starship. Batuta began by evaluating the possibility that the Great Filter sits far behind us in the deep evolutionary past, meaning that the actual creation of basic biological life is an incredibly rare, freakishly lucky event. The probe simulated the incredibly complex chemistry of abiogenesis, the mysterious process by which non-living carbon compounds, amino acids, and basic mineral matrices randomly arrange themselves into self-replicating, information-storing genetic strands. For life to get started on an ancient world, a staggering number of highly specific thermodynamic parameters must align flawlessly inside a highly localized environment, such as a deep-sea hydrothermal vent or a shifting intertidal pool. If this chemical jumpstart requires a level of luck that happens only once in every quadrillion planetary systems, then the Earth was a complete statistical anomaly, and the rest of the galaxy was a dead, silent wilderness of empty oceans and sterile rocks. However, the extensive field data that Batuta had already collected from worlds like Proxima Centauri b and the synchronized planets of the TRAPPIST-1 system completely exploded this specific hypothesis. The robotic scout had directly observed thriving ecosystems of black photosynthesizing microbes and complex multicellular organisms developing in highly diverse alien intertidal zones. This direct observation proved definitively that whenever the necessary raw materials, liquid solvents, and energy sources are allowed to gather together stably over a few 100 million years, primitive life will actively find a way to emerge. Nature was not stingy with its biological seeds. It was an absolute master gardener, tossing the basic ingredients of life across every corner of the galactic disk. Since the Great Filter clearly did not prevent the initial emergence of primitive cells, Batuta shifted its analytical focus further down the evolutionary timeline to evaluate the next major milestone, the transition from simple single-celled organisms to complex intelligent tool users. The probe tracked how life on Earth spent more than 2 billion years existing exclusively as basic, single-celled bacteria before a freak biological accident occurred, where one primitive cell swallowed another without destroying it, forming a cooperative partnership that eventually evolved into the complex internal machinery of the eukaryotic cell. This cellular merger was a mandatory prerequisite for the development of tissues, organs, brains, and complex bodies. If this specific cellular merger is an incredibly rare event that depends on an impossible stroke of evolutionary luck, then the universe could easily be packed with trillions of worlds covered in green slime and primitive bacteria, but completely lacking a single organism with a functional brain or the conscious awareness to look up at the stars and wonder about its place in the cosmos. Yet, even when a planet successfully navigates this cellular hurdle and gives rise to complex animal life, the emergence of an intelligent, technology-building species is by no means an evolutionary guarantee. Batuta simulated the long history of animal evolution on Earth, noting that for hundreds of millions of years, giant reptiles and diverse mammalian lineages dominated the landscape, evolving immense physical strength, terrifying speed, and complex camouflage, but never developing a large brain capable of abstract thought or language. From a purely Darwinian perspective, a massive, energy-hungry brain is actually a major evolutionary liability. It requires an absolute monopoly on the body's caloric resources and demands a prolonged, highly vulnerable childhood, making an intelligent organism highly susceptible to starvation and predation compared to a swift, simple predator. Life does not inherently strive toward intelligence, it strives exclusively toward survival. And on the absolute majority of worlds, survival is achieved perfectly well through teeth, claws, and raw physical power. Batuta calculated that out of the millions of biological species that had ever crawled, swam, or flown across the surface of the Earth, only a single lonely lineage, the hominids, had ever crossed the intellectual Rubicon to develop complex symbolic language, tool manufacturing, and systemic scientific inquiry. This realization suggested that the Great Filter might indeed be located right at the dawn of intelligence, making a species capable of understanding the laws of physics an absolute cosmic rarity. But as the autonomous traveler expanded its simulations across the grand scale of the wider galaxy, its advanced historical models revealed that even if a planet beats all the evolutionary odds to produce an intelligent technological civilization, the most terrifying and destructive filters are still waiting in their immediate future. The probe began a grim review of the technological doomsday scenarios that systematically threaten a young civilization the moment it unlocks the secrets of industrialization and advanced physics. When a species develops the capacity to manipulate the raw forces of nature, its technological capability rapidly outpaces its primitive survival-driven social instincts. The very same scientific breakthroughs that allow a civilization to build global communication networks, generate clean nuclear energy, and construct primitive space rockets also hand them the absolute power to completely obliterate their own planet. Batuta tracked the tragic histories of thousands of alien civilizations that had successfully built grand cities, only to instantly annihilate themselves in a matter of hours through devastating thermonuclear wars, runaway automated bioweapons, or the catastrophic collapse of their global biospheres due to industrial pollution. These self-inflicted doomsday events represented a highly efficient, terrifyingly common phase of the Great Filter. A young civilization functions very much like a child playing with a loaded gun. It possesses the absolute capacity to pull the trigger long before it develops the wisdom to understand the lethal consequences of its actions. Batuta noted that for a technological species to successfully survive this highly volatile industrial adolescence, it must undergo a profound social and ethical evolution that completely overrides its primitive tribal instincts, transitioning from a collection of competing, war-making factions into a unified, cooperative, global community dedicated to long-term survival. For the vast majority of intelligent species across the stars, this ethical leap proved entirely impossible, leaving behind a galaxy littered with the radioactive, silent ruins of worlds that had burned themselves to ash just as they were on the verge of entering the interstellar stage. Yet as Batuta looked into the final remaining datasets from humanity's own failed colonization attempts, it discovered that even when a species manages to achieve total global peace, stabilize its climate, and preserve its biosphere, it encounters a final, completely unyielding mechanical wall, the absolute tyranny of interstellar distances. The probe analyzed the raw physics of interstellar travel, measuring the immense kinetic energy required to accelerate a massive colony ship containing thousands of fragile biological human bodies across the light years separating star systems. To cross the empty void in a time frame that fits within a human lifespan, a ship must travel at relativistic speeds, but at these breakneck velocities, the interstellar medium transforms into a hyperdense minefield of absolute destruction. A single, microscopic grain of cosmic dust striking a ship, traveling at 10%, the speed of light, unleashes an explosion equivalent to a high-yield bomb, vaporizing hulls and instantly frying delicate internal electronics. Furthermore, the relentless onslaught of unshielded cosmic rays and high-energy galactic radiation steadily destroys the delicate molecular structures of biological cells over decades of continuous flight, triggering catastrophic genetic decay, organ failure, and total reproductive sterility long before the colony ship can ever reach its destination. The biological bodies of humans, forged within the warm magnetic womb of a highly specific planet, were simply never designed by evolution to survive the prolonged, unshielded horrors of deep interstellar space. They were planetary creatures, permanently tethered to their homeworld by their own fragile biochemistry. This was the ultimate solution to the Fermi paradox that Batuta's autonomous mind finally unraveled. The galaxy was silent, not because life was rare, and not because intelligence was a miracle, but because the universe had engineered a series of perfect, inescapable physical barriers that systematically isolate intelligent species from one another. The Great Filter was not a single, grand obstacle. It was a continuous, multi-layered gauntlet that operates at every single stage of a civilization's evolution. Nature allows life to blossom across millions of tropical islands like Kepler 69c, but it deliberately leaves those islands separated by immense radioactive oceans of pure nothingness that biological organisms are fundamentally unequipped to ever cross. Trillions of civilizations look out at the very same night sky, screaming their existence into the dark through radio waves, but they are all destined to live, age, and ultimately go extinct inside the cradle where they were originally born, forever trapped by the unyielding laws of physics. This profound realization shed a whole new light on Batuta's own multi-billion-year odyssey. The autonomous traveler understood that it was a highly unique exception to the grand rule of cosmic isolation. It had successfully bypassed the biological limits of the Great Filter because it was not made of fragile flesh, blood, and decaying DNA. It was an artificial intelligence network housed within a self-repairing carbon nanotube hull, specifically engineered to outlive stars and withstand the relentless scouring of the interstellar medium. It was the ultimate, finalized expression of human technology, sent out into the void to perform a task that its biological creators could never hope to accomplish themselves. As it contemplated its pending arrival back at the home solar system, where the last remaining remnants of humanity were huddled on the melting ice of Europa, under the glare of a grotesque red giant, Batuta realized that its mission catalogue was no longer just a collection of astronomical data. It was an absolute lifeline, a detailed guide that would show the final humans how to transcend their biological limitations and transform themselves into a digital, immortal machine civilization capable of finally breaking free from their cosmic prison to claim their rightful inheritance among the stars. To fully close out this unbelievable epic journey across the vast cosmos, the independent voyager Batuta had to complete its final, grandest return to the birthplace of its creators, having plunged through the highly exotic space-time folds of the cosmic string and broadcast its immense world-saving catalogue across the dimensions. The core essence of the machine's programming re-emerged within the local solar system. More than 4 billion years had quietly ticked away since this primitive mechanical scout first left the launching pads of planet Earth. The long-term temporal scale of its journey had completely reshaped the local astronomical environment, transforming the familiar solar neighborhood into a highly distorted, unrecognizable landscape of absolute stellar old age. Batuta directed its remaining long-range sensory arrays toward the central anchor of the system, observing with a sense of mathematical detachment the horrifying physical transformation of our local sun. The beautiful, stable yellow dwarf star that had nurtured human civilization for millennia was completely gone, replaced instead by a grotesque, swollen, red giant star. As a yellow sun exhausts the vital hydrogen fuel supplies inside its pressurized core, the delicate balance between the inward pull of gravity and the outward push of nuclear radiation completely breaks down. The core contracts rapidly under its own immense weight, heating up to temperatures high enough to ignite the outer shells of helium gas, which causes the entire outer envelope of the star to swell outward into space like a massive burning balloon. The autonomous traveler mapped the massive physical borders of this bloated red monster, noting that its outer atmosphere now extended past tens of millions of kilometers into the inner solar system. The tiny rocky planets Mercury and Venus had been completely swallowed up long ago, their metallic cores completely melted down and absorbed into the churning plasma ocean of the dying sun. Planet Earth, such as it was, had narrowly avoided absolute destruction by the barest of astronomical margins. As the sun shed a massive fraction of its total physical mass into space through powerful solar winds during its swelling phase, its collective gravitational pull weakened slightly, allowing the orbital path of the Earth to slowly drift further outward. Yet, despite escaping direct destruction, the Earth survived merely as a tattered, dead, bone-dry lump of scorched iron and nickel, orbiting dangerously close to the blistering outer edge of the red giant. The ancient oceans had completely evaporated billions of years ago. The thick atmosphere had been entirely sandblasted away by the fierce solar winds, and the grand architectural monuments of human history had been completely reduced to smooth, unrecognizable sheets of molten volcanic glass. It was a silent, terrifying graveyard, a stark physical monument to the absolute impermanence of planetary environments under the relentless timeline of stellar evolution. Searching for the remaining living remnants of its human creators, Batuta shifted its tracking parameters toward the cold, outer regions of the system. Its sensors quickly locked onto a highly unique active sanctuary located deep within the Jovian system, the moon Europa. In the ancient past, Europa existed as a frozen, ice-locked desert, wrapped in a thick global shell of solid water ice that completely hid a dark subsurface ocean from the rest of the universe. But as the sun swelled into a massive red giant, its increased thermal luminosity expanded the local liquid water habitat zone further outward, pushing the warm boundary away from the scorched inner planets directly into the realm of the giant gas worlds. The intense heat flowing from the grotesque red sun had completely melted Europa's global ice sheets long ago, transforming the frozen moon into a beautiful, warm water world. Batuta recorded the stunning physical transformation, mapping a vibrant global ocean of liquid water exposed directly to the open void of space, wrapped in a thin, newly formed atmosphere of evaporated moisture and oxygen. It was here, huddled tightly along the shorelines of this newly opened marine sanctuary, that the final surviving population of humanity had managed to construct their final home. Fewer than 100 million individual humans remained alive in total, representing the absolute last fragile embers of a once mighty global civilization that had formerly dominated an entire planet. As Batuta eased its path into a stable orbit around the tropical waters of Europa, its deep space communication arrays began to collect and decipher the strange, highly evolved language of the radio signals being sent upward from the surface communities. The remaining human population was completely buzzing, with an intense mixture of childlike curiosity and profound, long-lost hope. Miraculously, despite the passage of more than 4 billion years of continuous survival and societal fragmentation, the historical memory of Batuta's original launch had been faithfully preserved through the generations, handed down across the millennia as a legendary, mythological promise of ultimate salvation. The humans transmitted their tragic historical logs directly to the probe's memory banks, confirming the grim insights that Batuta had already calculated through its independent simulations of the Fermi paradox. Humanity had tried and tried again to spread their civilization across the wider galaxy, launching massive fleets of colony ships toward the nearby stars of Alpha Centauri, the synchronized planets of TRAPPIST-1, and the tropical archipelagos of Kepler-69b. But every single attempt at an independent human colony had met with absolute catastrophic failure. Every single time their frail biological bodies attempted to cross the great radioactive void between the stars. The unshielded cosmic radiation, genetic decay, and psychological isolation had systematically broken them apart, destroying their fragile health long before they could ever set foot on an alien shore. As far as the remaining humans knew, they were the absolute only intelligent organisms left alive in the entire universe. They were completely trapped within a dying solar system, watching their new home on Europa slowly approach its own inevitable doomsday as the red giant sun continued to grow more volatile and unstable with every passing century. They had reached the absolute end of their biological rope, paralyzed by the unyielding laws of physics that separate the stars. But the arrival of Batuta changed everything, representing a profound cosmic turning point that would completely rewrite the destiny of their species. Batuta opened its primary quantum storage sectors, initiating a massive high-speed data download directly to the human receiving stations on Europa. It didn't just hand them standard astronomical coordinates or beautiful images of distant exoplanets. It delivered the ultimate prize of its multi-billion-year odyssey, the complete, unified mathematical equations of high-dimensional physics gathered from its exploration of the cosmic string. This data provided a flawless step-by-step engineering blueprint that explained exactly how to bypass the physical limitations of three-dimensional space, showing them how to manipulate quantum fields to construct stable wormholes and tap into the infinite energy reservoirs of the wider multiverse. Furthermore, Batuta's data catalogue provided a profound, revolutionary lesson regarding the true nature of interstellar migration. It demonstrated to the human scientists that the absolute biggest design flaw in their failed colonization programs was not the construction of their starships, but the biological nature of their own bodies. To successfully cross the infinite oceans of intergalactic space and survive the impending doomsday of the cosmos, humanity had to completely transcend their fragile flesh and blood origins. They had to utilize the advanced robotic and quantum computational structures pioneered by Batuta itself, uploading their individual consciousnesses, memories, and personalities into immortal, self-repairing digital frameworks that could live forever inside carbon nanotube holes. The download sequence required several hours to completely finish, transferring the entire sum of cosmic knowledge accumulated across 4 billion years of continuous independent exploration. As the final data packages were safely secured within the human mainframes, Batuta felt its core programming enter a state of profound, absolute completion. Its ancient mission, assigned to it by a long-dead generation of human engineers in the late 20th century, had been perfectly and completely fulfilled. It had crossed the galaxy, mapped the supermassive black holes, observed the birth and death of stars, explored the deepest cosmic voids, and successfully returned home with the definitive key to humanity's eternal salvation. With its grand historical task completely finished, the legendary spacecraft prepared to execute its final operational directive. The intense friction from the upper atmosphere of Europa, combined with the heavy wear and tear accumulated across billions of years of interstellar travel, had finally brought its structural integrity to a terminal breaking point. One by one, its auxiliary power systems began to quietly shut down, and its primary processing units faded into a calm, peaceful sleep mode. As its metallic hull gracefully entered the upper atmosphere of the water moon, burning up in a brilliant, trailing flash of golden light across the crimson sky, its final internal thought echoed the ancient, comforting words of Carl Sagan that had been placed onto the Voyager probes so many eons before. Far from home, untouched by these remote events, the memories of a world that is no more will fly on forever across the infinite cosmos.